Welcome, everyone. This is Michael Gibbs. I'm the founder and CEO of Go Cloud Careers, and I'm so excited to be here with you today. Today, we are going to talk about multi-cloud architecture. It's going to be some strong cloud architect training, and we're going to talk about high availability cloud architecture design. And when we talk about things today, we are going to get really deep. So let me tell you the format for today. We'll talk a little bit about Openstack and Openstack clouds. We'll talk about the benefits of multi-cloud, what is multi-cloud, and we'll really talk about all those skills, not only to get that cloud architect job, but to be able to design really critical high availability systems for your customer. I will say this, for the last couple of years, we've been telling people that a single cloud is a single point of failure and one of the most ridiculous and dangerous things we've heard. And I'll tell you why a single cloud is a single point of failure. Companies have to have a multi-cloud strategy, and that's why we're doing some multi-cloud training. So let's talk about why a single cloud is a single point of failure. And I know most of you are cloud certified, either as certified solution architect professionals or Azure experts, but here's the thing. Let's talk about the cloud. So a cloud really is a network in a data center that's somebody else's. So you build a cloud, you install a cloud computing control plane on top of your network and data center, and poof, you have a cloud. So if you ever want to look up what is OpenStack, or you look up an OpenStack cloud, now you know. You know what a AWS is? It's a data center and a network with the same cloud control plane software, and that's what chops it up into a cloud. So we're really talking about networking and data center concepts. Now, when we design network and data center concepts, we make sure that we have no single points of failure. The military has an expression that says, 1 is none, 2 is 1, and 3 is greater than 2. And what do they mean by that? It means that if you only have 1, it's going to break. And if you have 2, you're good, because when your primary breaks, your backup will work. And then they say 3 is better than 2, because chances are your primary will break. So this is when we talk about high availability network design. So we're going to get deep into this. So if you're having fun and you're excited, type multi-cloud architecture in the chat box, and I know you're going to be ready. And while you're typing multi-cloud architecture in the chat box, so I know you're ready, I'm going to talk about why a single cloud provider is a single point of failure. Now, I want you to think about this. Let's say we've got this beautiful cloud, the AWS cloud, the Azure cloud, the Google cloud. These are really well done clouds. And I love these clouds. They're my experts in network and data center technology. So we're dealing with the best and the brightest people in the world. But let's look at a single cloud. If you listen to AWS or Azure or Google, they'll say, if you need high availability, just use 2 availability zones. That'll get you to 99.99% available. And if you need more than that, 2 availability zones in 2 regions, and you get to 5 nines. Now wait, why can't that ever work? Because a single cloud is a single point of failure. Why is the single cloud the single point of failure? What happens if the underlying network has a problem at the cloud provider? Well, all their availability zones in all their regions are down. If the network's down, it's all down. That's a problem. We've seen this with AWS. We've seen it with other cloud providers. Okay, now let's look at the other problems that occur. It's not just what happens if the control plane goes down? We've seen this with the cloud providers where some of their management software goes down. Again, it takes the whole cloud down. You have an issue in US East and it's affecting people in Europe and South America and Africa. Why? Because it's the same cloud, it's the same network, it's the same control plane. So we've got network failures, which we can't compensate no matter how many data centers, availability zones, and region we use. We have a common control plane. And if that breaks, guess what? Your whole cloud is down. Now, let's talk about security. Why is the cloud a security risk? Well, hack into my house, you got pictures of my cat Cindy. You get to see what my students are doing, because that's what happens if you hack into my house. Now, if I hack into Azure, like somebody did, and they got in and they got all the customers' information that were using their database, I've got access to thousands of customers at one time. So who am I going to hack as a hacker? I'm going to hack the cloud. I'm going to find my best hackers and hack the cloud, because if I access the cloud, I can shut down the internet. I can hold companies ransom and hostage. So a single cloud is a problem for three reasons. They share a common network. They share a common control plane, and one hacking event could destroy the whole cloud. So there's three situations that no matter what you do, by being on a single cloud in multiple regions and multiple availability zones, you can go down. So now let's look at, can you really design high availability on the cloud? Did AWS deliver 99.99%, which is not even high availability to anybody this year? No, it's a couple of hours of outages, and they've had much more than that all in a single day. So kind of keep that in mind. Do I think AWS is an amazing cloud? No, I think they're awesome. Do I think Facebook doesn't know how to run their network? No, I think they have some of the best network engineers and architects in the world. I know some of them personally. They're amazing. But still, somebody made a configuration change, a mistake on BGP, and it caused $8 billion to Facebook in a single day. And these are the things that happen on the network. So today we're going to talk about building the foundational architecture. I'll give you a scenario. We might do some hybrid cloud and multi-cloud. We're going to build the architecture first. And what I mean by that is we're going to talk about how to do the high availability systems design, how to do it. And we are going to get detailed and geeky. I'm going to get to have fun for my youth, and we're going to talk about where to put the redundancy. And this will not be covered in any Azure expert. It will not be covered in any solution architect professional. The only people that know how to do these are a very few number of CCIEs that have been designing these systems for service providers and banks for the last 50 years. I've been doing it for 20 years, and actually 25, and I've consulted to the world's largest organizations and service providers, people that need 99.999+% availability, and they achieve it every day. So let's talk about what this means. The first thing we're talking about with high availability system designs are no single points of failure. So where's the most difficult challenge of anything? It's actually with our infrastructure, the network that is the underlying component. So when we build our systems, we have to think about the network. So I'm going to ask you all, for those of you that have not been working as network architects like me, if I've got two connections between two locations, I have to choose two different service providers. Would I put both of my links on AT&T? No, because if I have two links on AT&T and AT&T goes down, my connection to the cloud is down. And you know what? For the last 30 years, not a single person has ever bought two connections from the same service provider because it's too risky. But when you go to the cloud, all your network connections are on the same service provider. No redundancy whatsoever. So when we start doing the architecture of this, we have to make sure that there's no single points of failure. So we're going to be looking at the routers. We're going to be looking at the power. We're going to be looking at the cooling. We're going to be looking at the switches. We're going to be looking at what goes on in these devices. How do we make them work under extreme circumstances? So the first thing we're going to start talking about is the connectivity to the cloud. The thing that most people never think of, because unless you're a network architect, you won't know. So we're going to give you network architecture things. What is the cloud? It's a virtualized network in a data center. What makes you a great cloud architect? If you know the network. So let's start talking about the network stuff. So let's think about this architecturally speaking. Chris, can you bring in my PowerPoint window real quick so I can try and, okay, perfect. Thank you so much. So everyone, what we're going to do is we're going to focus on the connections to the cloud. Now, let's say right now, we are designing the systems for a hospital. And for some reason, this hospital is really rich because some billionaires just left a couple $100 million endowment and they don't care about cost, for argument's sake, because I want to teach you how to build the best. Now, this organization decides we're interested in the cloud and they want to connect to the cloud, but this organization is really concerned. If they put their systems on the cloud and the links to the cloud go down or the cloud goes down, patients will die. So this is a critical high availability architecture. Systems goes down, people die. So do you think we can have any single points of failure here? No. Do you think we could be on a single cloud? No. Do you think we could just have a direct connection and a VPN backup? No. There's too many risks. So realistically speaking, let's look at this. Let's look about this real high availability system design. Let's do this. Now let's look at the customer side. They need connections to the cloud. So let's talk about what these connections are. How many of you think it's a good idea, and you can type it in the chat window, to go buy some $5,000 commodity router and use that to connect into the cloud? If you think it's a good idea, type good idea. And if you think it's a bad idea, type bad idea in the chat box right now. And then I'm going to tell you why. But I want you to think it through. I want you to work it through. I want you all to become expert architects. It's a bad idea, Marla. It's a terrible idea. Jamal, excellent. Leo, it's a bad idea. We are not going to use the $5,000 commodity router that they talk about in your AWS Certified Solution Architect Professional class to connect to the cloud. If we do this and the router dies, guess what? We have nothing. We've got nothing. We're dead in the water. So what does this router, should it look like that connects to the cloud? Well, let's build our router right now. So let's design it, and I'm going to show you what a high availability system does. Because if you don't get this right, guess what? Nothing's going to matter. So let's talk about the stuff that nobody talks about. So where do the things that go wrong in electrical devices? For one thing, they lose power. Okay. Now, if we have all these things with a single power supply and the power supply fails, like on that cheap $5,000 router, what happens? Network goes down. Now, what happens if we've got a single circuit breaker that goes down? Network goes down. So what are we going to work around? All of that stuff. So what does this device look like? And our connections routers to the cloud are going to be expensive. We're going to need two power supplies here. We'll call this PS1, and we'll put another power supply in here. This is a high availability router now. Now, let's look at this. So now we've got one power supply plugged into one circuit and one power supply plugged into another circuit at the data center. Now we've got redundant power. So do we think these are just run into power outlets, or do we think our data center has the following? Power coming in, uninterruptible power supplies that are battery powered to clean the power, and a generator and a backup generator to make sure that our power works. Well, if high availability matters, we have two circuits, two generators, and two UPSs just to plug into these routers. And if you're dealing with a healthcare organization or a big bank or an internet service provider, this is going to what it be like. And yes, we'll need two power distribution units. Exactly. All on different circuits. Cesar, exactly. Now, every device has a CPU or a brain. Do you think maybe the CPU or brain could crash or fail? Yeah. So what do we want in these routers? We want redundant control modules or redundant brains. And by the way, so we're going to have a control module. We'll call it a CM over here. Let's add a second one. Okay, good. Now we've got two control modules. So now we're dealing with something. The main brain on the switch can fail, and we're still connected. Or a power supply can fail, and we're still connected. But we've still got single points of failure over here, which I don't like. So now let's say we've got this thing over here, and it's called a line card. Let's say over here on this line card, let's say here's where our gigabit Ethernet ports are plugged in, or our 10 gigabit Ethernet ports. Let's look at it this way. So let's say I've got a connection coming out of this 10 gigabit Ethernet port. What happens if that line card fails? In the chat box, tell me what happens if that line card fails. That's got the gigabit or 10 gigabit Ethernet port. What happens when that line card fails? Where the port's plugged in? The network is down. It's dead. Exactly. Do we think this is a good idea? I don't. Everything goes down. So now, how do we really build a high performance routing connection to the internet? And this is the way you should do it. We put multiple line cards in here. Let's say we've got two line cards. Now, what if we put a link on each line card? Better yet, let's put 4 line cards in here and put a 10 gig link to each line card. Now, with that link, let's make this a really powerful router. Let's have some fun here. Let's really make this, and this is the way I've designed systems for the last 24 years, or 25 years, and this is what my customers have demanded of me. So now we've got our control modules, we've got a line card here, control module. We've got another line card. Let's put another card where the 10 gigabit Ethernet ports go. Let's do this. Let's make this really redundant. Let's put 2 more line cards in here on this link. Because remember, this is a critical organization. So now let's put a 10 gig link or a gig link on each one. Now, is there anything we can do on these links? If we have 4 direct connections to AWS or Azure or Google, which I'm fine to use, how do we load share across them? We've got to use BGP. And we've got to create a BGP policy so we don't get out of order packets. And if you guys want, I'll teach you how to do that. But if we could take these 4 line cards and we could bundle them together into a link aggregation group. Now, 2 control modules, 4 line cards. We can lose a control module. We can lose 3 out of the 4 line cards and a power supply and still be connected to the network. Does that feel like high availability to you? Yes. Now, let's really think about this. Let's say the top router is connected to AT&T. Now, we need another. Just because this is a high availability router, are we really comfortable with this? I'm not. I want another. 1 is none, 2 is 1, and 3 is greater than 2. But we're now much closer. So now let's do this. Let's take another one of these routers. Now, with this, let's do the same thing. And then I'll show you why what AWS refers to as high availability is not. Let's say we've got all these. So now I've got 2 link aggregation groups. The top one is on AT&T. The bottom one I picked NTT. It's a Japanese telephone company. They're huge. They're all over the place. I've consulted to them. They're great. So now I've got a link on AT&T, American Telephone and Telegraph, and Nippon Telephone. So now am I redundant on my connectivity to the cloud? Do I have any single points of failure? I've got 4 connections across 4 line cards on the AT&T router, 4 connections across 4 line cards on the NTT router. I've got redundant power in both routers, redundant control modules, and link aggregation groups where any one of those links can go down, and we're still up. Robert, you're right. We have no single points of failure now. Now we're solid. Now, this is our direct connections or our WAN. If we wanted high availability, could we do anything else? We really want it to be perfect. Okay, so now let's think about this. What could or should we do for our internet access? Do you think we need 1 internet connection for VPN backup, or should we have 2? Tell me the number of internet connections you believe we should have in the chat box, because now we're going to create some VPN backups. Jazz 2, I like 2. Robert Welch 2. Marla, at least 2. Exactly, at least 2. Nike, Manoj, Marjan, Robert, exactly, we need 2. Okay, now, can anybody tell me what we need to use to connect to 2 different internet service providers at the same time to be able to use the most efficient routing and load share properly? Is there anything special that I need to do? Chris, exactly, 2 service providers. Derek, you got it. We've got 2 service providers. We need active and active. So how do we do that? Do I have 2 active default routes to the internet? No, I need to use BGP. Clarence, I need to use BGP on my internet service provider connections. BGP will enable me to take in a full routing table from the internet, and it'll enable me to determine the best path. Most specifically, I'm going to use eBGP because we're connecting our autonomous system to another autonomous system. So let's look at what our internet architecture should look like before we deal with the VPN piece, because our internet architecture matters too. And it's all going to come from the network. So let's have some fun with this. So let's look at our internet routing architecture. What does this look like? So now we're here. And now we've got, let's see if I've got a picture of a cloud. Because for those of us that have been around forever, we use clouds to represent the internet. The internet was a cloud, frame relay is a cloud, ATM was a cloud, VPLS was a cloud, BGP VPNs were a cloud, and I worked on them for decades now. So, okay, so now we've got our cloud, and this is called the internet. I need the cloud. So what's this going to look like? Well, if it really matters and our lives are dependent upon it, what we're going to do is we're going to have two of these routers. Now, when we connect to the internet, does anybody think we're using small and cheap routers, or do we need to use big, expensive routers? Why or why not? Can anybody tell me why our internet routers become expensive, and why they're all going to ultimately have multiple control modules, power supplies, and multiple line cards in them in most cases? Okay, here's the reason. When we get routes and a full internet routing table via BGP, we're dealing with 800,000 routes, at least. Now, when you connect to AWS, they let you send them 100 routes. We're going to be taking in 800,000 routes from 2 internet service providers or more, which means we've got a router that has the memory and CPU capacity to deal with 1.6 million routes in the routing information base for it to run things. So we're dealing with massive routers. When you're dealing with massive routers, the routing companies, Cisco and Juniper, assume that when you're dealing with that, you need a big, powerful internet router. So multiple line cards, multiple power supplies. So it's going to look like this. Now, we're going to typically do this. We're going to have one or more connections, internet service links like this, to our internet service provider. And we're going to have to do the following. We're going to have to take in these routes and make the best decision. So this will be over here, eBGP. And the reason it's eBGP is it's an external autonomous system versus our internal autonomous system. Now, so right now I want to walk you all through the high availability networking piece of this. So now, if I go out, if I learn a route on this router, these 800,000 routes from, let's say, this internet service provider, let's say it's AT&T. This eBGP. Let's say we've got AT&T. Let's go back to that NTT that we have here. They're a really amazing internet service provider. One of my most successful graduates worked there for a couple of years before we worked at Cisco and then in Zscaler. So let's say over here, let's say this is NTT. So let's make sure our graphics look a little better. I don't make any typos. eBGP, because I'm known to make lots of typos. So now, this router on the left knows all about the internet routes from the internet. The router on the right knows all about the routes from the internet. Does the router on the left and the router on the right know each other? Do they know about each other's routes right now if I do nothing? Or no matter which router you go to, that's the only place you're going to be. If you think right now the left router knows about the routes on the right router, put known. And if you don't think they know, type not yet or no. Okay, good. I'm seeing it come in. They don't know it. And why does the AT&T internet router not know about NTT's routes? Because they're not exchanging routing information between them. So how do I share the information between the AT&T device and the NTT device? What do I have to enable between them? What is that protocol I need to enable? Is it internal or external? What am I trying to share? What about this? We can't use an we are going to use an IGP between the routers, Jazz, for network layer reachability. But if we do a loop back to loop back connection to share the routes, we're going to have to use IBGP. And IBGP is going to enable these two to exchange routing information. So what will enable IBGP is you'll have an IGP such as OSPF or intermediate systems to intermediate systems on your network. And that will advertise your routing information, like to be able to reach each other's stuff. And then from there, you'll pop it into BGP. First rule of BGP, if the next hop is unavailable, don't put in the routing table. So if you don't have your IGP, eBGP is not going to work. So IBGP is not going to work. Now, this will be transitive because we're only one hop away, NitroPad. We don't have anything to worry about. Now, if we had more than one hop, we'd have to enable a route reflector to enable transitive routing or fully mesh our peers. But right now they're fully meshed and there's only one hop. So we don't have to worry about it. So now we've got these two internet connections. So do we now have stable and reliable internet connectivity? Yes, we do. So now, if these are our primary links to the cloud and our backup links, maybe, guess what? Maybe we should have a VPN backup. Now, do we put it on these same routers? We could. Or do we use another set of routers? So if the AT&T router in all of its glory were to fail, and the NTT router in all of its glory were to fail, we now have internet connections from somebody else and another router. Oh, and by the way, for our internet access, let's do this. Let's take this off of AT&T. Let's put this on Verizon, and let's put this on CenturyLink. Let's make our internet service providers on a different network than our regular service providers. And that way we can tolerate AT&T dying, NTT dying, and we'll still have Verizon and CenturyLink to back up. You see what we're doing here? It's like an onion, layer after layer after layer after layer. So now we've done this. Now we've got this. And now let's do our internet routers. Now we need VPN connections. So let's do this. Let's get another set of routers. Now, these VPN connections are backups. They are backups. We have 4 primary paths to the cloud. We have 4 backup paths to the cloud. And we've got 2 internet service providers. Now, if this is a critical 5 nines route available network, you know what we're going to do? Those routers are going to look just like this. But we might, if we chose to, if we needed to save a little less money, if we wanted to save some money, we could potentially use a smaller router for the VPN backup. Why? Primary, backup. VPN is a tertiary backup. And oh, by the way, by having 2 internet connections, we've got better performance on our VPN, and we've got some guarantee that our VPNs are coming up. And note that our VPN connections are on different carriers, different service providers from the AT&T and the Verizon we're using to connect to the cloud. So now we're on 4 networks compared to the AWS network, which is 1 network. So now we're really approaching high availability. So let's do this. We don't need link aggregation groups on our connections to the cloud. We're not going to have all these extra line cards. We're just going to have a single one. We are still going to have redundant control modules and redundant power supplies because we want to plan around failures. Now we've got 2 VPN routers. VPN 1. We're going to do VPN 2. Now, I know what you're all thinking. AWS has told you you only need 1 connection because it's a high availability device on on the AWS side. And guess what? That's true. When you connect to this thing on the far end, let's say this is AWS. When you connect via a VPN, here's what it does. It's going to make something to your availability zone, and that VPN is going to create a little connection to a second availability zone, which is really kind of cool and logical and fun. So we think we're doing something great here, but now let's think about this. If you've got 1 router connecting to 2 availability zones and your router dies, guess what? You're dead. You have no network. It doesn't matter what AWS says on their end is reliable. If I only have 1 router on my end and it connects to the AWS 2 routers on the end, does anybody see a problem? What happens if my router dies? AWS says it's okay. They say you only need 1 link and it creates all these private virtual interfaces and takes you to multiple availability zones. What happens if the router dies on your end? Somebody put that in the comment section below. What happens if your router dies? What's your connectivity like if you only had 1 router connecting to the cloud? Leo, you got it. Everything dies. Margin, everything dies. There's no failover. So it's irrelevant how available that logical device is at AWS. They did a great job, but we're still dead in the water. We're dead in the water because we've got nothing to AWS. So great. The airplane that I'm going to fly to Florida, that I'm going to fly to New York in, has 4 engines, and if 3 of the engines fail, it can still get me there. But if I can't get to the airport because I don't have a car, there's no Uber, and there's no taxi service, it doesn't matter how robust that airplane is. So when you take that certified solution architect professional and they tell you, oh, you only need 1 because it's redundant on their end, but your end is not redundant, so it doesn't matter. Do it that way, you've got a single point of failure. Your router dies, your connectivity dies, you've got no cloud computing. Now, in this scenario we're building, we've got patients in the hospital. Their medical records are on the cloud. We need to know. We don't know their drugs, their allergies, their medications. The connections to the cloud go down. People die. Somebody makes a BGP misconfiguration on AWS. People die. Somebody makes a control plane failure. People die. Somebody hacks into the cloud. People die. So that's why we're talking about real high availability systems. So now let's think about this. How do we make this good? So now we know on the data center side, we need multiple clouds. I mean, we need multiple routers, redundant routers, different circuits, different PDUs, different WAN connections, different service providers. A lot of them. Now, what happens if in the data center where these things are plugged in that are connected to the cloud, what happens if the ACs break? And that room goes from 70 degrees to 130 degrees. Do we think our systems are up and operational? No. Do we think we can put these kind of things in a wiring closet with no power, cooling, or maintenance? No. So what do we need? How do we keep these systems up and running? We've got to have redundant air conditioners. Redundant everything. So now they'll overheat and we'll be dead in the water again. So these are the kind of considerations, redundant redundant everything. So whether you connect to the cloud or in your data center, you still have to think about these things, because if you don't architect them into your environment, you'll go down. We don't want to go down. We want to go up. So now let's think about what this is going to look like. That's why we've got this nonsense, and I don't consider any of this to be relevant. So this is what we're talking about now. Ultra high availability systems. So just keep that in mind. And at some point today, I might design an Openstack cloud with us on the data center side too, because I love Openstack and I think we should talk about that. But let's look at this now. Let's figure out what a real cloud architecture would look like. So now, let's walk through the alternatives. So right now, I've got my data center. We can call this data center, or we can just call this office. I don't care. Now, let's walk through these again, and we're going to show you what to do instead. According to AWS, if you wanted 4 nines availability, all you'd have to do is use 2 availability zones, because if one availability zone goes down, the other is going to be perfect. Now, we've seen time and time again across multiple cloud providers that doesn't work. But, let's just evaluate that. So let's think about this. So now we've got 2 availability zones. One over here. One over here. We feel good. Everything looks good. We're connected the way AWS told us we're here. Now, you got Joey. Joey went out to a party last night. Joey got really, really stoned. He got really, really drunk. Joey showed up for work and he made a BGP misconfiguration error on the network backbone. How's our hospital? Patients are dying by the minute. Are we happy? No. Now, Joe shouldn't have gone to the party. Joe shouldn't have gotten stoned. Joe shouldn't have gotten drunk. But reality is things happen. So we're going to plan around this. So let's think about this. If, by comparison, we need 5 nines availability, and we know that a cloud data center is 3 nines availability, because they've told us that. Why is a cloud data center 3 nines available? Why can you build a regular data center 4 nines available? Why can't you do that on the cloud? Well, let's think about the cloud. The cloud has a control plane, this miraculous software that takes this regular environment and chops it into really magical things. Do we think that adds complexity? Have any of you ever built a cloud? Have you ever installed that control plane and set up your storage and your virtualized networking? There's a lot that goes to this. Regular data center, you install VMware ESXi, you set up your servers, everything's beautiful. Bob's your uncle. Cloud, you've got a lot of complexity. So all it takes is Joe to get drunk and you're down. So now let's think about, how do we make this good? How do we make this better? What can we do? Well, let's think about this. If we're going to work on the assumption that a cloud provider can deliver 4 nines availability in 2 data centers or 2 availability zones, and no cloud providers delivered that this year because of the outages, not a single one has been able to get anybody close to 4 nines. But let's just pretend for a second that they were able to. Now we've got a 4 nines cloud. How many times do we need 4 times? If we take 3 nines and 3 nines together, that gives us 4 nines. If we take 4 nines and 4 nines together, that theoretically gives us 5 nines. So what do we need to use according to the cloud providers to get to 5 nines? We need 2 regions and 2 availability zones. Okay, 2 regions, 2 availability zones. Okay, but why do we not do that? Single cloud, single network, single control plane, single plane of failure. But working on the theory that 2 availability zones gets us to 4 9, and we need 2 availability zones and 2 regions to get to 5 9s, let's think how we make it better. Let's now do this. Let's say we've got 2 clouds. Cloud A, call this Azure. Azure. Who I love. Now, let's take AWS, who I also love. Other than the way they name things with the cryptology, the cryptographic names, like to me, I'd call a virtual machine, not elastic compute cloud. So with AWS, when you're doing your training, strip the word elastic off of everything and you'll know what it is. Or just translate it to the ultimate sources. So now we've got Azure and we've got AWS. And if people ask me why I think AWS likes funny terms, Azure calls it a content delivery network. AWS calls it CloudFront. Azure says this is a virtual machine. AWS calls it elastic compute cloud. You know, pretty easy. AWS has an elastic load balancer. Azure has a load balancer, so you know exactly what it is. So I like calling things, what they are. I call my cat a cat. I don't call my cat a horse. My cat runs real fast, but she's a cat to me. So it is marketing, Brandon. That's all it is. The problem is when marketing causes complexity. So now let's take these offices. So now we've got router 1, R1, which is our primary, R2, which is our backup, now, should we have a VPN router here too? Is the third one at least? Do we need a backup VPN, or is the fact that we've got a primary link, a secondary link, and our backup VPNs are across 2 internet service providers on fully redundant environments? We're going to have at least one VPN backup. And, I'm probably not going to go crazy over here. I'm going to just call this one VPN. So now what I'll do is I'm going to have four links, say, across one internet service provider or one service provider at Azure and a link aggregation group. So we can lose line cards, power supplies, ports, and links. Now I'm going to do another one. I got a backup. Now I've got my VPN backup. Now I've got a VPN, a primary, and a backup. I am really rock solid. Now let's connect this to Azure. Let's do the same thing to AWS. By the way, we'll call this router 4, router 3, because it's going to be separate routers for each one, because I don't want any single points of failure. Stuff happens, things break. We are working around everything. Okay, now we've got another set of tool links. Link here, link here, link here. So how much redundancy do we have here? We have 8 links, 8 direct connections to Azure, and 8 direct connections to AWS across multiple line cards, across multiple routers, and we have 2 internet connections as a backup. Are we solid now? You guys think this is going to hold up? It will. Now, AWS goes down. Somebody fat-fingered something. They got hacked. Guess what? Azure's up. Azure gets hacked. AWS is up. Are we available now? Do our systems work now? Yeah. Now they're going to work. Now, how do we make it better? How do we make it more robust? How do we make it scale? I will get into the cloud stuff, but if we don't do this first, what we have is a beautiful cloud architecture with networking that's just going to die and it's not going to work. So we want to get really detailed on the network. And that's why I'm getting heavy. So now let's look at this. So let's think security first. If we get hacked, does that have anything to do with our security? Would a hacking event cause us to have an outage? If you think hacking equals less availability or poor security, it has an effect on your availability, type security equals low availability in the chat box, and I know you'll know it. Yeah, we got a problem. We got a problem if we get hacked. So let's think about this. So excellent, Marjan. Excellent, Marla, Theo. Let's add a little more to this. Let's look about the addressing. Let's figure this out. So now, home. AWS. Azure. Okay. Now let's think about really locking this stuff down. Does anybody really know what is the key determination of how big you can grow, how much you can scale, and how optimal your routing is? All these three enormously complicated things that I just talked about are going to be based on the silliest thing you've ever heard in your life. Your ability to create an IP addressing scheme, your subnet and your supernet plan has a bigger impact on your ability to design an architecture than anything else. Subnetting? Yes. The subnetting will determine your addressing scheme. The subnetting will determine what your routes look like. Your subnetting will determine your traffic flow, and your subnetting will determine your availability or lack thereof. So now let's look at this. If we have in here, in our home or our data center, the 192.168.0.0/16 CIDR range, and in the AWS environment, we have the 172.16.0.0/16, and in Azure, which I spelled incorrectly, which I will fix, I'm not really Mr. Speller, I've got the 172.17.0.0.6. So let's do this. Now, let's, for argument's sake, I'm going to draw a connection from here to here, and I'm going to draw a connection from here to here. Now, for the security, for the availability, for the performance we need to really win, what subnets does the home need to know about? Enter it in the chat box. What two subnets does home need to know about? Enter them in the chat box. This is really, really, really important. It's not the private they need, but it's a good start. We need to know at our data center, home needs to know the 172.16.0.0 from AWS. And home also needs to know the 172.17.0.0 address, which are both in the private subnet range, but that's the CIDR range that I need to know. I need to know that and only that. So on this link, if from here to here, the only route that I need to know about, because we were intelligent about our subnetting, is 172.16.0.0/16. Now, this is what I should learn on this link. What about other links? What if another link comes? What about the 172? What about 172.18.0.0.16? Should I be able to reach that? Should I learn that from AWS, given that it's not part of my addressing? No. In fact, if I learn any other routes other than that 172.16.0.0, it's because somebody's injecting routes into my system. If somebody's injecting routes into my system, it's part of a hacking attack. So what would I do to make sure that I only learn 172.16.0.0? Well, we're going to do a couple of things. We're only going to advertise 172.16.0.0 in BGP. What else are we going to do? At this side here, maybe we'll use an access control list on the router. And we're going to do two things. We're going to do a distribute list on the route in, which doesn't let us learn the route. And then we're going to do another access list to make sure that only traffic from this subnet can actually reach us on this link. So some policy-based routing and some route filtering and also some traffic filtering. Now, we've done this. What subnets, type it in the box, should I learn on the link from Azure? What do I want to see in the route table from Azure? I got to get one big giant /16 subnet from Azure. It is the 172.17.0.0.16. So if I'm getting that via BGP, and then on the bottom link, I'm getting this done. And I use some access control lists and some route filters. I prevented myself from getting bad information. Now, if I've got a hacker that's coming to me they broke into AWS, a hacker, some really evil guy or girl gets into AWS, and they want to come into me, and their source address is 2.3.4.5. Are they getting through? No, because they don't have a route to it, and I've filtered them out and blocked them on a minimum of an access control list. Minimum. So they're not getting through. So what I want to do is as follows. I effectively want to firewall off AWS from me, and I effectively want to firewall Azure from AWS. Now I've got a military-grade security environment that I'm protected on my connections. I'm really rock solid. So this is a high availability cloud architecture. Now, we're going to have a lot more fun with this, and we're going to do some things. What if I were to tell you that right now, this hospital got a $200 million donation? Now, after this hospital got this $200 million donation, the hospital bought 5,000 of the newest AMD EPYC servers that all have 128 cores and 6 terabytes of RAM and NVMe RAID arrays. Let's say we've got 5,000 brand new servers a month ago because they were gifted to us from Dell. And we just happen to have F5 give us a bunch of brand new network load balancers. And we happen to have a brand new Dell EMC storage array. And we've got all kinds of really cool stuff in our building. Could we use any of this technology for something? All brand new technology to improve availability and system performance? Anybody have any ideas? NitroPen, yes, private cloud time. Exactly. So let's think about this. From an architecture perspective, what is the cloud good at? What is the data center better at? Now we're architects. We're not just techs. We didn't just pass a certification class that's the name of the service and how to configure it, which is fine if you're an engineer, but not an architect. We're architects. So what is the cloud really good for? The cloud is good for agility, speed of deployment. The cloud is amazing. Does the cloud, generally speaking, have more scalability than our data center? Is it easier to get a capacity? Okay, now I connect to US East. I'm 1,000 miles away. Any challenges being 1,000 miles away from the cloud provider in terms of latency? Yeah, that's what this whole concept of the local zone or edge computing is. The performance to get to the cloud is so slow from a latency perspective. The edge locations, the whole point of it, the local zones that they're talking about are edge computing. It's designed to get you closer to the cloud so it doesn't feel so bad. The latency is better. What's the lowest latency in the world? If I'm in the same building as my servers, is that less latency than if my servers are 2,000 miles away? Yes. If I've got a financial trading application that's going to trade 1 million shares of stock 15,000 times a day, and I can buy it a millisecond or a nanosecond faster than my competitors, and I can buy it for 10 cents cheaper for 1 million of them which would be $100,000 extra earned if I can do it in nanosecond cheaper than my competitors. And if I could sell that stock a nanosecond or faster than my competitors, I can make another 100,000. That's competitive advantage. Are we sticking that in the cloud? No, no way. It's too far away. There's too much latency. But is there any place else in the entire world that can do a web app as good as the cloud? Seriously, think about it. A web app, we set it up, it can dynamically scale up as we need. I mean, that's just beautiful, beautiful, simple and elegant. So we want to leverage the cloud for what it's good for, which is a lot, that agility, that scalability. So now let's say we do this. Right now, we can get to, temporarily speaking, if we design this, this theoretically should get us to 5 nines. It should. And it will, most likely. But do you know how we can guarantee it? What if we turn this office into a data center? Now, in our data center, we build our network. Everything in our network looks like this. Actually, let's design the network so you can see it. I want you to see what a strong network is going to look like. And this is the way it's designed. So I want you to see where we get concepts like decoupling coming from, because it's all networking. This is what a real network is going to look like, and this is what a 5 nines network is going to look like. We're going to have a couple of core routers. It's going to be core. They're going to look like this. And these are going to be huge, big, giant routers, a couple $100,000 each. And then what we're going to have is we're going to have a bunch of these connections between them. Maybe we'll have maybe 400 gig connections between each switch, and that'll be part of like a link aggregation group. And now what we're going to do is try and figure this. And now let's say we do this. For argument's sake, I'm going to pop in another 4 over here. One, they're not going to be the most beautiful things in the world because we're just doing it on the fly. Let's say click, 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 click. So this is the core of our network, and we're going to have 3 segments of our network. We're going to have a core, we're going to have a distribution layer, and we're going to have an access layer. And I'll show you what we do this and why we do this. Now, and for argument's sake, let's put a couple of, we'll obviously do some link aggregation groups in this way, in this direction. Now, we lose line cards, we're good. We use links, we're good. We lose power supplies, we're good. We'll use root control modules, we're good. So this is basically the core. And every network is going to have a core. And the core is your really high-powered stuff. Hold on, if I can do this, send it back. Okay, so that's our core. Now, what we're going to do is we want to feed stuff into the core. So, how do we do that? We create something called the distribution layer. And that's another set of switches. Now, these switches are big and powerful switches, but they're not like these. And basically speaking, you're going to have a switch. And it's going to be connected here. And it's going to be connected here. And this is your distribution layer. It's a pretty redundant switch. And then you got other switches called your access layer. And these are little mini switches that all feed into this switch. And why? What's the whole point of this? Well, I'll show you in a second. If this switch, let's call this A, B, C. If A fails in our decoupled environment, is it going to affect the core? No, because it's isolated over here. Hopefully, not always, but hopefully, if something happens in A, it won't affect D. Not always, but hopefully. Remember, it's a common network, so we're isolating our network. Now, something happens on B, hopefully speaking, it should be isolated to B because D is protecting C. Same thing over here. So that's what we're talking about. A core and access to distribution. Network load balancer, bunch of web servers. Network load balancer, a bunch of app servers. SQSQ, database. Didn't we just decouple the living daylights out of that? Same as this. Where do you think all that application architecture comes from? It comes from Cisco networking 30 years ago. It's all the same. So now we know what it looks like. So how do we take our data center and turn it into a cloud? First, we get the network straight. What do? Well, we take this really great software from Nutanix. We take this really great software from a Red Hat, OpenStack, or Ubuntu, whatever you want to use. We install Linux on our servers, which installs KVM, the Linux hypervisor, which installs Kubernetes, which installs a management plane. It typically installs a NoSQL database like MongoDB to actually maintain all the information about your customers and your subnets and your whatever. You set up your storage and now you've got a cloud. So let's look at this. Now, we've really overbuilt the situation, but we're talking about extreme availability of clouds. We're talking about clouds where if something goes down, somebody dies. This is the world I've lived in for the last 25 years. If something goes down, people die. So we build differently. So when we do this, let's look at what this is going to look like. So now I want you to really think about this from an architecture perspective. We've got a data center that's 4 nines. Easy to do. Openstack cloud. Now, we've got this. We've got Azure and AWS. And we've got multiple connections between them. Okay, now, what's the availability of this? 4 nines, 4 nines, and 4 nines. Almost 6 nines, meaning 99.9999%. It's somewhere in between 5 nines and 6 nines. How much downtime do you think we're talking about per year in 5 nines? 5 nines. 5 minutes and 15 seconds of downtime per year. Has AWS delivered 5 nines this year? No. Did Google deliver 5 nines per year? No. Did Azure deliver 5 nines to anybody this year? No. Because it's 5 minutes unplanned downtime. And they've had outages lasting hours. Now, 4 nines, basically 5 hours of downtime. Has any cloud provider across multiple regions and availability zones been able to not have 5 hours of downtime this year? No. So that's why you need multi-clouds. Now, in this situation, what's it look like? Now, we architects, let me ask you questions. Now, we've got this multi-cloud environment. Exactly 5 minutes and 15 seconds of downtime per year, Amrath. Good math. Exactly. So now, let's really think about it. Really want you to get really get this deep down. Web apps. If we have an external facing web app where patients and family members can go look at what we do and they can see our cardiothoracic surgery, that we're best in orthopedic surgery. If that goes down, does anybody die? Our informational website? Does anybody die? No. Doesn't matter. Now, what about our medical records? If we can't access our medical records, the things that tell the doctor what medications you're on, whether you had a heart attack, stroke, cancer, what your blood levels are, if you're anemic or polycythemic, or if you're having erratic heart rates, do you think that's important information? Or what blood type you are, or what medication allergies you have? You think we need to know that? Yeah. Okay, now, what's the best place to stick that for us in this architecture that's in front of us? The stuff that's so critical that if our network went down, it wouldn't work. Where should we put it? Do we put it in the data center, Azure, or AWS? Where should we primarily host that? Pop it in the chat box. Amrath, exactly, in the data center. It would like a data center. Margin data center, exactly. Millicent, Ah, Derek, I like that. All three would be totally appropriate. Nitropan, all three would be, but the data center should be your primary. Why? Because if you lose all your links to the cloud, nobody's going to die that way. Remember, we've got 8 links and 2 backup links, but stuff happens. Stuff happens. I might plan to deliver something by January, and we might be talking February. Stuff happens. So the point is you plan the best you can. You build your primary plan, your backup plan, your backup plan, and when it all comes down to it, adapt, improvise, and overcome. So put that stuff in the data center. Now I'm going to ask you all the web stuff. Let's say we're going to have a big, beautiful website, and we think we're going to get lots of demand. I'm going to have a billionaire spend $100 million on digital marketing to tell everybody that we're the best cardiothoracic surgery center in the world. Now, we got a website that's going to advertise this. We're going to have videos and audios. It's going to be a big, beautiful website, and it's going to get tons and tons and tons of traffic. We expect 100,000 views a minute. Where do I stick that? Nitropan, cloud. Yes, cloud. Why? Because it's going to scale. So we're going to figure out exactly what we need, and we're going to build it. We'll pre-warm load balancers. We're going to use the best of the cloud. We're going to use the cloud for its purpose. We are architects. We are not technicians. We transform businesses through the use of technology and workflow redesign. So we've got to know business. So that website's important to us. That's cloud. Now, I've got an IP-enabled medical device where if it can't go to the network, somebody dies. Do I connect it 2,000 miles away, or do I connect it to my local network? I connect it locally. So that's what we're trying to do. We're going to put our things where they need to be. We're going to maximize the leverage of the cloud. So for many organizations, putting the critical stuff locally is a very smart thing to do. And in this particular environment, why is local so beneficial to us? What benefit would the customer gain from leveraging these 5,000 AMD 128 core servers with 6 terabytes of RAM? What will that do for the customer? How could that or would that be better than the cloud? Pop it in the chat box. It's going to be better in multiple ways. Low latency, Amaranth is one of them. What about performance? Which do we think is better performance? A server in my local data center connected over to the network over multiple 100 gig links, or 4 10 gig links to AWS? Better performance in the data center, exactly. Now, I want you to think about high IOPS things. Let's say right now, I need a very high disk input output. I got a website that I need lots of input, output, a million times a second. Let's say I need 2 million IOPS. Am I going to get that in the cloud? Okay, well, a standard provision IOPS one is 64,000. I put 10 of them in a RAID 0 way, I get to 640,000. I add 20 of them, I get to 1.8 million. I add 30 EBS volumes, and guess what? I now can get to the performance of what I can do from 2 NVMe drives, which are basically for about $400 worth of drives on the cloud. I can spend $4,000 a month and still not get the same data center performance on disk. There are things that are so elegant in the cloud. There's a new IO2, which you can get a 500,000 IOPS or 250,000. So you would only need 10 of them. The point is I can get you better for $50 at Best Buy than you can for $1,000 a month on AWS. And it's not because AWS isn't awesome. They're amazing. Block storage is network storage. It is shared storage, and it does not perform anywhere close to local storage. But you can't do local storage in the cloud. Local storage is instant storage, which is ephemeral storage. It goes away with reboot. Can I do local storage in my data center? Can I write directly to a RAID 5 NVMe RAID array that's got 8 terabyte drives in it? Yeah, I can. I could even better than that. I could have a RAID 0 and another RAID 0 array. The point is you, the architect, need to know what you're doing. If you need 1,000,000 times 1,000,000 IOPS, guess what? Data center. You need more scalability, cloud. You want the most survivability and the best performance? Do it both. Go hybrid. Want to be really available? Go multi-cloud and hybrid. So now let's walk it through. Let's start looking at what this kind of architecture could be like. Let's say we put everything in the data center except for our web apps in the cloud right now. So now let's really think about what this is going to look like. And then we'll walk through it. So let's say it's a web architecture. What goes into a web architecture? We need an internet connection, right, everybody? We won't do the internet connection yet, but let's see. If I have 5 web servers, what do I need to do to be able to load share 5 web servers? Is there some kind of a device in the data center I would use, or virtual device in the cloud? What's that called? It's called the load balancer, exactly. 5 web servers, I need a load balancer. So a load balancer is a device to improve performance and availability by sharing the load through multiple devices. It removes single points of failure. Do I like load balancers? Yeah. For that reason, it removes single points of failure. So we're going to use a load balancer. Now, let's analyze the load balancers. We're going to use 10 web servers that all have 128 cores and 6 terabytes of DRAM. What kind of load balancer am I going to use for these 10 servers with 128 cores? NVMe RAID arrays and 6 terabytes of RAM. Would I be using an application load balancer or a network load balancer? Jazz, exactly, a network load balancer, because I need speed. Speed. Now, if these were 2-core servers, I would use an application load balancer, but I need something big. So I'm going to use a network load balancer. Now, I need servers, web servers. What are those devices called? Am I going to be using a physical server on the cloud? The whole thing? Am I going to go walk there? Can I install my operating system and then my dependencies? Or am I going to basically get a virtual machine on the cloud? Let me know if it's a bare metal server in the cloud or if it's a virtual machine. It's a virtual machine. Marjan, it's a virtual machine. Does exactly, it's a virtual machine. So what do I need? I need a virtual machine. Let's get a virtual machine. Okay. Got 10 application servers. What do I need to load share across application servers? Do we need any kind of device? And NIMIT, we're never going to talk as architects. You'll never hear us mention terms like PaaS or SaaS or EC2 or S3. There's no point for us to go there. And here's the reason, NIMIT. I need you to know virtual machine. And I'll show you why I need you to know virtual machine. Because I want you to learn how to drive the car, not learn how to just drive a Mercedes, and then need special training to drive a BMW and then special training for a Honda. So we're going to show you why I want you to know the real technology. We need a virtual machine. And as Raul and Marjan and Mel and Derek, all my students said, we need a load balancer to load share across our app servers. Okay, now, our app servers, what are we sticking them on? Bare metal servers or virtual machines? Somebody tell me in the cloud. Wait do you see till we turn this into 3 different cloud architectures in 3 seconds. And now you'll know what I mean by learn to drive versus we need another virtual machine. Exactly. Okay, now we've got a database. Now we're going to get a million hits, 100,000 hits a minute. What kind of databases are going to scale that big? And the database will be on a virtual machine as well. But what type of database should I think about for big transactions? Now, granted, the reality is in an environment like this, we'd use a relational database for transactions and a NoSQL database for scalability. But for right now, let's just pick a NoSQL database. I called out Nimit, who mentioned EC2. And I want you to know why. No, Jazz, we can't use Aurora here. And we can't use DynamoDB, and we can't use any vendor branded anything. We have to be smart because we're using multi-cloud. So let's look at the reasons why I would never use an Aurora or a DynamoDB in the first place. To use these, we're dealing with serverless, which means I've got to go spend a tremendous amount of money to recode my applications. Now, I've recoded them and I stick them on DynamoDB, and AWS raises my rates by 30% next year. Now I got to pay millions of dollars to recode my applications to get off. I'm now locked in. But if I chose Apache Cassandra or MongoDB, I can get in and out of any cloud at any one time, and I can be on AWS, Google, Azure, and Oracle, and synchronized all at the same time. So pretty much all the cloud formation is trash to me. Terraform instead is what the DevOps people are going to use. Any of these hosted serverless things, I'm not using them. I can't use them because they're not vendor agnostic. I need stuff that's really going to work anywhere. So now let's look at this, which is why architects don't do what certification says. So relational databases would be great here. So now let's think about this. Let's have fun, everybody. Let's design this for 3 clouds. Okay, what does AWS call their network load balancers, everybody? They call it an ELB because they have to stick the word elastic in front of it. Google sticks the word cloud in front of everything that they do. So what's this load balancer called on Google? Google's going to call it a cloud load balancer. Same tech. Now, what does Azure call it? They call it an Azure load balancer. This is why we drive the car and we don't learn to drive the Honda. Okay, now we need a virtual machine. We're going to start with AWS. What's AWS call those virtual machines? They made up some ridiculous term called Elastic Compute Cloud. Okay, we'll call it EC2. They've got some really expensive, fancy marketing people. What is Azure going to call their virtual machine? Oh, wait, they're going to call it a virtual machine. Now, what's Google going to call it? Compute engine instance. Where do these people make up these terms? But really fancy marketing people, compute engine. Guess what? It's just a virtual machine. Now, we're building 3 clouds here. And this is why I say learn to drive the car, not the Mercedes, not the Honda. Now we need another network load. We have another network load balancer. Okay, wait. AWS calls it Elastic. Google calls it a cloud load balancer. Azure calls it a cloud load balancer. Okay, these are the name of our services. Okay, now we're going to stick those services in. And this is the way you design every architecture. You never think of the vendor until the end. Oh, wait, I need another virtual machine. Oh, EC2 instance, virtual machine, compute engine. All right, let's fill in those blanks. Now I need a NoSQL database. So what does that mean? It means I need a virtual machine. We know what they are. EC2 instance, Google Compute Engine. And now I need a NoSQL database. So what would that look like? I've got a choice. Apache Cassandra, MongoDB, and the database architects, our big data architects that we're going to talk to, they're going to ask us about read and write. And MongoDB performs better in a more balanced area versus, Apache Cassandra. But there are 2 options. Completely different architecture. Apache Cassandra is meant to be run on a large number of commodity servers. MongoDB is a little different. So just kind of keep that in mind. So now, this is, realistically speaking, the way you design a cloud architecture. So what did we start with? We started with the end goal in mind, which is the website. Then we mapped out what the website needs to look like, and then we fill in the blanks. Okay, so let's really talk about this. And we can build this out if you guys want. And so now we know what our web architecture looks like. Now, what do we need to connect this to the internet? Let's just pick AWS right now. What do you think we need here? We need an internet gateway, exactly. So now we need to connect this little device. We're gonna go to the internet over here. Now we need the internet gateway to connect to it. So, does the internet gateway need a public address or a private address? Type public address or private address in the chat box so I know that you're here and paying attention. Also, while you're at it, if you're having a good time, if you can hit the like button or share or tell others to join. I'm trying to learn how to be Mr. YouTube. Love YouTube because it enables us to have conversations for free all over the globe. And I find that just fantastic. It needs a public address on the internet gateway. Exactly. A public address. Why did Amazon come up with the term public address? Of course, they called it an elastic IP because they stick the word elastic in front of everything. But you got to look at it from a marketing strategy. It was pretty smart. Now, from I want to learn how to be a cloud architect perspective, it's really challenging because then you don't know what it is. But from a marketing perspective, it's brilliant. So we need an internet gateway. Now, we also need a public IP address on something else. What else needs to be public? The external facing part of that website needs to be reachable from the internet. What is the external facing part of that website? Is it the web server or is it the load balancer that front ends all those servers? It's the load balancer, exactly. We need to put a public IP address on the load balancer. Load balancer. Now we've got connections. Now, does that load balancer need a route to anything? Do we need any routes here to make this work? What's this? What's this mean? Doing that. What's that route? It's default route. What does that mean? It means if you don't know where to go, go here. So we're going to need a default route that's going to point to the internet gateway. And that's how the routing is going to occur. So far, are you guys with me? Okay. Of course, you need a route table. A route table is going to tell you how do you reach your destinations. Absolutely. So, you guys want to secure this architecture? You guys want to come up with a robust security that'll work on any cloud, anywhere, anytime? All right, let's build some robust security here. Lock it down. I want our systems to work. So, what do we think we need to protect us from the outside in? Let's say we want to put a perimeter up. We need a firewall. Dennis, you are correct, the next generation firewall. What are the many reasons we're not going to use any of these kind of WAFs or any of these kind of certification firewalls, why we're going to use a real enterprise grade firewall? Okay, here's the thing. What does WAF protect against? Layer 7 attacks. What are we concerned about? Everything. So WAF is never going to be good enough. Additionally, that if we use an AWS WAF on one and there's an Azure WAF somewhere else, do we really feel good that we're going to get the identical security from two different companies who have two different, homemade virtual firewalls? I don't. Now, looking at what's been going on, Facebook makes their own routers. They had an $8 billion outage. The rest of the world buys their routers from Cisco and Juniper. Facebook thought they could make their own. They had an $8 billion outage. AWS makes their own routers. They make their own. Banks buy them from Cisco and Juniper. So now, let's think about this. Do I want the AWS people that just made in the last few years their firewall? Or do I want to go to a company that's done nothing other than made firewalls for 20 to 30 years? and they've done billions and billions and billions and billions of dollars and trillions of dollars in firewall sales, and they're used by every bank, every major healthcare organization, and anybody that really matters. That's what I'm going to use. So I'm never going to use Wafer Shield. That's part of your certification, but that's not what you do for a living. Certification is how to the name of the service and how to configure it. Reality is what you're going to do. So let's talk about how we're going to secure each cloud. Now we have to use vendor neutral services. Now, me as an architect for 25 years, I'm telling you what I'm going to do. I'm going to call Cisco, I'm going to call Palo Alto, I'm going to call Fortinet, and I'm going to say, send me your best and brightest cloud security architects, and I want to collaborate with them. And I will work with them to design my thing with my security experts in those. I will always do it. I don't know Cisco as well as Cisco unless I work for Cisco, because that's all they do. So let's start thinking about what we're going to use. We are going to have to add some form of a DDoS protection. So we typically need a content delivery network. I don't care if it's Akamai, I don't care if it's Cloudflare, I don't care if it's CloudFront, I don't care if it's the Azure Content Delivery Network. But let's just say we put a CDN at the edge. So we need a CDN. And we're going to put on the CDN some DDoS protection. Now, let's begin by looking at firewalls. We need a real, we need a powerful, we need an exceptionally strong, a really, really, really strong firewall. Now, I'm going to ask you this question. Can any of you walk over to AWS, walk in the building, go to the rack, screw into the rack your firewall, and plug it in and cable it up? Can any of you do that? If the answer is yes, type it in the chat box. If the answer is no, type no in the chat box. Exactly, Kajoy Jazz. We can't go walk into the AWS data center and say, I want a real firewall. I bought these two $50,000 things from Palo Alto and I'll plug them in. They don't let us. So on the cloud, we are stuck with other stuff. So what we have to do on the cloud is we have to work around the weaknesses of the cloud. So on the cloud, I want a good firewall. What do? I can't go put one in there, but I can go to the marketplace and I can get my Cisco firewall that runs on a virtual machine. Whether it's an Azure virtual machine, a compute engine thing on Google, or a virtual machine on Azure, it doesn't matter. So I go to the marketplace and I buy them. Now, if I buy a virtual machine, just a virtual machine, not a hardware appliance, and that virtual machine crashes, is my firewall dead? Yeah, it is. So I can't use a single firewall now, which means when I go to the marketplace, I have a problem. The firewall is a virtual appliance. So is there any technology that we could use to load share across multiple servers to then make sure that we can improve performance and availability, that might have a health check that could potentially remove a bad device from circulation? How can we do that? How do we load balance between servers? Is there any kind of device for that? Tell me the name of that device in the chat box. It's a load balancer, exactly. So we need a load balancer. So regardless of where we're at, we're going to use a load balancer. Now in the data center, it's not uncommon to use a network load balancer to load balance between firewalls. The load balancers do health checks. So what we do is we're going to use a load balancer to actually load balance between firewalls. And it's typically speaking, it's going to be a network load balancer. Now, in the AWS environment, they came up with the concept of a gateway load balancer, which is basically doing the same thing as a network load balancer used to do, load balancing between network devices. But keep this in your mind. So now we're going to use more than one firewall, because 1 is none is 2 and 1 is 3 is greater than 2, right? So let's say we use a Palo Alto firewall here. I feel bad because I spent most of my career at Cisco, but I'm really loving these Palo Alto firewalls the last couple of times. I'm going to have a Palo. These are great devices. So what I'm going to do is I'm going to use a network load balancer, gateway load balancer equivalent, and I'm going to load balance between hardware. Now, in a data center, it would be a hardware load balancer, but we're here in the cloud. So we don't have any kind of hardware load balancers. We've got virtual load balancers, so they're software devices. But in the data center, it would be a high availability, high performance load balancer, most likely from F5, but not here. So let's start thinking about what we can do with our networks. Now, the CDN, the content delivery network, will only forward valid requests to the server. It will drop invalid requests, so that's going to provide a lot of DDoS protection. Next, we're going to hit a network load balancer, and we're going to load balance between two next generation firewalls. What is a next generation firewall? A next generation firewall is an adaptive firewall. A next generation firewall does a lot of things. A next generation firewall has included intrusion detection and prevention. Next generation firewalls don't trust anything. They can enact things in real time to stop attacks. Yesterday, one of my students said, "Hey, guess what, Mike? There's a new vulnerability. What do we do about it?" And I said, "Nothing." I said, "Here's the thing. What do we put in all our architectures? We put next generation firewalls. We talk about, patching systems and disabling unnecessary services, etc. And the reason we do that, the reason we're not using these WAF devices and we're using next generation firewalls is we're preparing for attacks that we don't know about ahead of time. So that's why, if it matters, we're not going to be using a WAF and a shield. So we're going to be using these next generation firewalls. So look at it this way. We knock them out with the CDN and keep everything out of the firewall. You guys know what firewalls do? They let your external traffic out and your return traffic back. But any external traffic comes in, they get blocked, 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 blocked. So that's why. Now, we get past the CDN. Some hacker gets past our firewalls and our intrusion detection, all that cool stuff. Now they've hit our subnet. Is there anything we can do in a cloud provider to protect our subnets? Type it in the chat box. What we can do to protect our subnets. Let me know in the chat box. We can protect our subnets with a network access control list. Excellent, excellent, excellent. So we're going to put a network access control list. Now, AWS has them, Azure has them. They all have some equivalent of this. Okay, now we got some pretty robust security here. Let's play a little more. Let's have some fun with it. Now that protected our subnet. Is there anything that we can do to protect our virtual machines, keep stuff from entering our virtual machines? What is that thing that AWS has and Azure has to protect your virtual machines? Security groups, exactly. We'll pop in a security group while we're at it as well. You guys think that's enough? Are we rock solid now? We've got network access list, firewalls, intrusion detection, content delivery network, shield protection. Are we solid? Do you guys think we have a good security architecture now? We're not done. We're missing a lot. And I know this is far above what we've taught in a certified solution architect professional, but we've just scratched the surface. We need more. What about our servers? Can we do anything with our servers? Can we lock them down? We need a lot more. Ahmad, nice job there. Okay, so on our server here, why don't we put a host-based firewall as a secondary firewall? Now, anti-malware, yeah. I like that. What about disabling unnecessary services so we're not listening on NTP or this thing or that thing? Exactly. So we're going to disable it. Srinivas, I'm so happy to see you here, and I'm so happy you're having a good time. So we're going to disable unnecessary services. Now, what else are we going to do? This is part of our maintenance, so this is going to be more of our sysops people. We still need to know about it. Derek Houston, exactly. Close unnecessary ports, remove unnecessary applications, post-ball firewall, but we're going to patch it exactly like Joy said, who's also one of my amazing students. We're going to patch. It'd help if I could spell. So we're going to patch these systems. Okay, we're having fun. So now they got a bypass our content delivery network and our DDoS protection. They got to bypass our firewalls. They got to get past our network access controllers, security groups. The next host-based firewall, our anti-malware protection, and we've got our servers hardened. Okay, Ahmad, really? We've got more stuff to do. I think you're right. We've done no IAM whatsoever. The ability to determine who you are, what you're allowed to do, and then track it. So, they come up with this term of identity and access management, which is a very complicated term to talk about what we used to call AAA. Authentication, who are you? Authorization, what are you allowed to do? Accounting, what did you do? So we need that. So let's add some IAM. Now, we're going to be working with 2 clouds. What do we think is a scalable way to do IAM that's going to work? Let's say we've got 100,000 employees in that hospital. I'm so happy to hear this, Nimit. Active Directory, exactly. Do we have one person that's just going to go there and manually type in 100,000 users in 2 clouds? We're going to use an identity provider like Active Directory. Okay, so let's use some Active Directory, which means if we use Microsoft AD, got to federate it to it, right? So with AWS, it'll be AD connector. And we're also going to be using Azure. What's Azure call their thing? Azure AD. So will be covered in both. Jazz is right. We're going to use a SAML 2.0 connection to federate with this. Now, we got this guy, Joe. Joe likes to drink and do drugs. And he makes a lot of configuration mistakes, and we don't want to fire Joe. So, is there any way that we could make sure Joe who's a cloud engineer working for us, could only make sure that Joe could only deliver things that are good, only good stuff, and he couldn't misconfigure anything? Is there a way that we could give Joe some kind of a template and he could only deploy good stuff so that he doesn't put bad stuff on our systems that are not locked down? Can we do anything about that? Is there any way? We could limit his permissions. Yeah, Raul, we could use AWS config. We want to lock down what people are able to do. So use AWS config, use a Terraform script that somebody made, something. Because if Joe likes his alcohol and drugs and we're not getting him better and we've chosen not to fire Joe, we're going to have to lock Joe down. So it's a permissions thing, it's a policy thing, and we should template good configuration. Let's say while we're at it, let's say we use something like config. Now, let's say somebody breaks in and steals our hard drives. Can we do anything about that? So that if they get access to our systems, that we're going to encrypt it. Yeah, exactly. So even if we do a service level policy, we're not breaking ourselves down into organizations in this particular case, but it could be useful, Jazz. In this particular case, we're looking for something. So we're going to encrypt the disks. So on Azure, do we have to do anything to enable encryption? You're right. We enable the key management system on Azure. What do we do on AWS? What do we do on Azure? On Azure, it's included. We don't have to do anything. Okay, nice, huh? We don't have to do anything. So now what else? What about the people? Where is an organization's biggest risk? Okay, tell you what. I walk into the bank. I get to the bank, I see a guy. He's an obvious bodybuilder. He's got muscles bulging everywhere. It looks like he's taking a ton of steroids. Hi, sir. So nice to meet you today. You look really good. Could you tell me, do you work out? Yeah. What kind of workouts do you do? I'm from IT. I'm designed to work on this person's computer, but he's not here. Could you help find his password so I can do it? It's a really critical matter. Social engineering. Or the person that's at the front desk that just looks like they had a $300 haircut. And you walk over to her and you say, "Oh my God, I love your haircut. Wow, you look so extra nice today. You always look nice, but today you look so extra nice. You know, I received a call from this CEO and he told me that I needed access to your computer because you were so valuable and so important that I needed to get access to your systems. Could you give me a password so I can help upgrade you?" It's called social engineering. How do you beat this? You train your people what to look for. So we've got to do some security awareness training. So far, all this extra security stuff, do you think it's going to help our availability? Keep us from getting hacked? Yeah, now we're solid. Now, one of the things about the cloud that's pretty special, and as a rule, I'm not a fan of this serverless and domainless stuff. The cloud people love it because once you do that, you can't leave the cloud and you're stuck forever, but then you're locked in. I like transforming my customers' businesses and I like to give them the opportunity to improve their business and I like to give them flexibility so that if a cloud provider were to raise the rate, they can say, sorry, I'll go to the other cloud provider. I always use multi-clouds because if you have multi-clouds, you know what? You can negotiate better rates with your cloud providers. You've got a lot more wiggle room when you've got negotiation and bargaining power, and you have none when you're on a single cloud. So let's think about that. So we want to go multi-cloud. Now, what else could we do? Can we take a log in the cloud environment, like a CloudWatch log or an Eventbred log or anybody's log? Can we then use a log to kick off like a little mini software function to remediate something, like somebody sets up an S3 bucket, for example, and they made it public? Could we have CloudWatch notify it and maybe use something like a Lambda function to remediate it? Well, we could do CloudTrail API monitoring, but could we do something better? Could we do an event-driven security? Brandon, so happy you're back. Yeah, we're going to do some event-driven security. So how do we do that? Basically, what we need to do, we use to take something, and we can do this on any cloud. We can, and this, by the way, is really awesome stuff. So let's say we do this. Let's say we have CloudWatch. You know, CloudWatch can do a couple of things. It can kick off an SNS message to tell me there's a problem. But we could also do this. CloudWatch could also kick off a Lambda function that could remediate something automatically. You think this would add to our security policy? You think this would add to our security policy? Yeah, it's going to add a lot. What else? Can we do anything else? Here's a question for you, everyone. How many logs do you think we're going to get from an environment like this? Think we're going to get a little logs or a lot of logs? Jazz brings up an interesting perspective. So, guard duty monitors and detects threats continuously. Nice. Guard duty does a little bit of intrusion detection and prevention like work. What else in our architecture is doing that? The Palo Alto firewall. But, so if I was interviewing for AWS right now, I'd be adding guard duty to talk about all those cool AWS services I was using. Would I probably use it here? Probably not, because I've got the Palo Alto firewalls that are doing that. But let's assume I did. So let's add it to it. What else? So let's add guard duty to this architecture. Jazz suggested it. And if you guys were on an AWS interview, I would name as many AWS services as I possibly could, because they're going to like that. So let's add guard duty for that reason. I'm going to be using my Palo Alto stuff, but let's just add guard duty. Now we've got some pretty good things. What about all these logs? Little bits of logs, or Alonzo, a lot of logs. Kajoy, a lot of logs. Theo, a lot of logs. Is this log stuff real-time events? Or is it stuff that takes slowly? Do we get constant logs, syslogs every 10 seconds as soon as something changes? Or is it like they come out once a day? Lots of stuff, constant stuff. We could have VPC flow logs. We're going to have real-time logs. We're going to be getting non-stop. Are there any services that we could potentially use to take real-time data, analyze it, and then look at it? How could we do that? Derek, yes. Kafka, yes. So, can we take all of our logs? Let's say we've got a log coming in here. Got logs. If we send the logs to Kafka, which is a vendor neutral version of Kinesis, this is what the industry uses versus the AWS branded service. So we're going to use multi-cloud. We're not going to use any AWS service. We're going to use Kafka. Big data environment. Kafka does Kinesis functions, but are we going to use Kafka on Azure, AWS, and Google? Sure. Because there's going to be differences between Kinesis and everybody else's streaming thing. But the Apache is going to be the same, the Apache Kafka. So we're using vendor neutral. So pretty much like all those names of the services, when you want to do high availability, you got to get rid of it and you got to use generic stuff anyway. We're going back to the network in the data center, which is what a cloud is, a network in a data center. So now we're going to use Kafka, which is basically the same as Kinesis streams, but we just want something that's going to work in multiple environments. Now, could we do anything with this? When we have real-time streaming data, are there any kind of business intelligence tools that we could use to look at it? Okay, yeah. So we could use a Kibana. We could use like a Tableau or something like that. We can use some BI tools, or visualization tools. Elasticsearch on AWS, whatever. It doesn't matter. It's just we want to use a tool that can do it. Let's say we use Tableau, which is much cheaper than the AWS software, and it works on all clouds. So perfect. Power BI would be perfect, some of these tools. So now, did we just do a big data integration into our security to get better information? Yes. Do we have event-driven security here? Yes. Do we have a robust firewall solution? Yes. Do we have a robust traffic filtering solution? Yes. Do we have a robust host-based firewall solution between the security group, which is a stateful firewall, and the secondary host-based firewall? Yes. Are our servers hardened by disabling unnecessary services? Yes. Putting on anti-malware protection and patching them? Yeah, now we're solid. Now we've got a AAA authentication through Microsoft AD that's going to work on all clouds. We're using a service-like config to make sure that Joe, our bad employee, doesn't do anything bad. We're encrypting all of our data in case anybody gets access to our houses. We've trained our people to be more rock solid so they don't open that email that says free $1 billion, click here. We've got some guard duty, which is just going to use some machine learning to tell us stuff. We've got some event-driven security, and now we've got logs, which is going to go into Apache Kafka for real-time streaming data that we're going to visualize. Ronaldo, Microsoft AD or Active Directory is the most common domain authentication IAM product in the world. So I'm sure you know what it was. It was just not under the term AD. So they call it Microsoft AD. That's their term, not my term. I don't really like to use abbreviations for that reason. It causes confusion. So now you know. So now we've got this. So let's go seriously. Let's walk it back. In this environment, we're here. Now, we've done route filtering, access control lists. Our backups are now on these routers. Multiple control modules, multiple line cards, multiple power supplies, multiple circuits. You can see our connections. We've got a primary, a backup, and a secondary backup. So we're solid there. You've seen what our network looks like, our core access and distribution. You've seen this multi-cloud architecture looks like. The data center is connecting to two things. 4 nines, 4 nines, and 4 nines equal 5 nines and a half. It's pretty great. That means you're dealing with like 2 minutes of downtime per year, perfectly acceptable. We've got a multi-cloud architecture. So we've got our internet connections. Now, we obviously need a public address. You can call it anything you want. We use a load balancer on all three. Now, if this is an Oracle cloud, would anything change? No. Nothing changes. As if this is the Dell cloud, does anything change? No. If you're on the Palo Alto cloud, it's still going to work. Why is it going to work? We didn't use services like Kinesis. We didn't use services like DynamoDB. We use generic things that work across every cloud provider. So are our systems always going to work? Yes. If Microsoft Azure decides to raise our rates by 88%, does it concern us? No. Because we'll go to Google. Now we're on Google. Google wants to raise our rates. We're not serverless. Guess what we do? Well, you meet my price, or guess what? I'll go to Dell. I don't need you. That's the benefit of going vendor neutral. You're not at the mercy of someone. So when you go to a customer and you say, you should go serverless, and the CEOs look at you like you've got 4 heads, that's the reason why. AWS wants you to go serverless because when you're serverless, you can't leave. When I was at Cisco, people were using EIGRP, which was a Cisco proprietary routing protocol. I never used it. Why did I never use it? Because sometimes somebody might want to use a Juniper router or somebody else's device. And the second I used Cisco EIGRP, I couldn't. So even at Cisco, when I worked for Cisco, I still used open vendor interoperable solutions. Always. The second you go vendor proprietary, you lose all the flexibility your customers have. So the next time you think about a DynamoDB, think about why it's probably not a good idea. The next time somebody talks about serverless, think about why it's not such a great idea. You build your own Kubernetes cluster and you stick your containers on a virtual machine and it doesn't work. Guess what you do? Simply, you take a machine image of that virtual machine and you stick it on Azure, and 3 seconds later, it's up. Oh, so Ronaldo Naza, what migration technique do we use to migrate from one cloud to another? There's nothing to it. We make machine image copies of every single thing we have. And all we got to do is transfer our data and launch these things. We can migrate from one cloud to another cloud manually in less than 8 hours. And if we use Terraform, we could take our same infrastructure as code and lift and shift that to another cloud in 45 minutes or less. That's how easy it is when you don't go vendor proprietary. Now, it could cost you millions or billions of dollars to get off of serverless, based upon the company and how expensive their applications are. But this, no big deal. So let's do this. Since Ronaldo asked a really question, what migration technique would you use to migrate to? So anybody want to do some really cool, fancy disaster recovery? Anybody want to take this to a 6 nines available system? Okay, well, let's add some disaster recovery to our fun architecture. Let's pick the right kind. We have 4 options for disaster recovery. Let's talk about them. Option 1 is as follows. I've got my AWS cloud. How do we do this? Well, I'm on AWS. Let's take the same architecture. We've got our network load balancer, our virtual machine, a network load balancer, some virtual machines, and a NoSQL MongoDB database. Okay. Can I make a machine image of these things in 5 minutes or less using a tool? Yes. Okay, so I'm going to make a machine image of these things. Now, I've got images of everything, and I've got a data backup. Let's just take this data backup. So what do? I snapshot my data, and I make images of my machines. Now, what is disaster recovery type 1? It is the lowest performance, cheapest disaster recovery option in the world. By the way, everybody should know these 4. These are 4 critical questions that are going to show up on Cloud Architect interviews. And if you don't know these, it's going to mean you really don't know architecture. So make sure you get these down because they're real important. They pop up in interviews all the time. I ask people this, and if they can't answer it, I'm concerned. So disaster recovery version 1 is we take all these things. We take the virtual machines, we pop them. Let's say we're using AWS and right now we're using AWS and we're using Azure. So I go to Google. I now FTP up, or whatever the equivalent is. I transfer my virtual machine images to cloud storage on Google. I backed up all my data. Now on Google, I've got backups of every virtual machine that I have and all of my data. How much you guys think that cost me? Almost nothing. That is disaster recovery type 1. Now, let's say we use this. But while we're at it, let's walk through the other 3 types of disaster recovery. The first one is just backup, and that's real cheap. Let's say we wanted a better failure. Let's say if our data center fails and AWS fails and Azure fails, we want to be able to come up on Google. So now, the first thing we did is we made our virtual machines and copied it all over. But that's too slow. How do we make it faster? Well, I've got my AWS environment, my Azure environment, and now in Google, I keep machine images stored in cloud storage of all my stuff, but I've got a database that's running. And I synchronize my database between my data centers in Azure and Google. Now Google has a fully operational synchronized database and machine images. What do I need to do now? If anything fails, well, I've got to take my machine images and turn them into virtual machines. And I've got a synchronized database. Now, that's it. Now, do we think or feel really comfortable that in this particular environment, we're going to get the environment up and running quickly? We are not. Because if Azure goes down and AWS down, we have to launch those virtual machines, set up our load balancers and do our IP addressing thing. And, in a couple of hours, we're up and running. It's good. Now, we're talking about this, Ronaldo, because I want to walk you through the disaster recovery options. So now let's this. In our multi-cloud architecture, let's say now we went to AWS. We want something faster. We're now in Google, our backup cloud. Now we have small virtual machines running, a small environment of our data center. And it's all running in an auto-scaling environment. Since we're doing this in an auto-scaling environment, a failure happens in AWS, it shifts to Azure. Azure fails, DNS now shifts it to Google. Google systems are small, auto-scaling kicks in. Next thing you realize, we've got a whole bunch of web servers and our Google environment is up and running in 45 minutes. How can we make it faster? Well, the last option for disaster recovery is we could run a full up and running cloud on Azure. So we could have a full cloud in the data center, a full cloud on AWS, Azure, and GCP. Now, how available do you guys think that is? Real available. So that's extreme available, and they're all going to sync. So the question was, how do you migrate your stuff to another cloud? You make machine images, you transfer your data, and you launch them, and that's all you have to do. Now, if you were serverless, you'd have to recode your entire applications. It could take you weeks and months of application development, and you are really locked in. And cloud providers are like the cable company. In your first year, they give you a very discounted rate, and then they raise your rates, which enables many businesses to start their business and thrive. It almost self-funds them, which is amazing, but you've got to expect that big increase in your bill. And if you're serverless, you're stuck. If you're not serverless, you've got bargaining power, you've got negotiation power. These are the kind of things. And yes, Jazz, there are companies that are active on all clouds. In fact, if you're dealing with banks or people that it really matters, they're not crazy. They're not in a single cloud. They're in all of them. All of them. And they still have disaster recovery data. So they're in all of them. The only people that are doing this are people that don't know better. Now, there are times where it does make sense to go to a single cloud. Let's take a Netflix, for example. What Netflix does is amazing. And the way AWS works with them is amazing. It's an object storage based platform. No web servers, it's just a bunch of object storage for the most part. There is web servers, but and there's databases to main state. But the point is for them, as big as they are, if you can't watch your TV for 2 hours, nobody dies. So they don't need 5 nines. They can be 4 nines because their customers are regular people that have regular internet connections, which are not 5 nines. Nobody dies. So being on one cloud, they got bargaining power. And if AWS wants to raise the rates, Netflix says, do you really want to raise your rates? I'm one of your biggest customers. If you do, I'll be at Azure tomorrow. They're not raising their rates. So the point is there's times where a single cloud is good, but it's up to you, the architect. Remember, we architects aren't naming services and configuring them. We're advising businesses on how to operate better through technology. So we've got to be able to function on this. We've got to be able to do this. So we'll get into some more tech stuff soon, but we've covered a lot of tech. So why don't you guys ask some questions? And then after that, we can talk some more. I don't want anybody getting confused. I really want you guys really knowing what you're doing. So do you guys have any questions so far? If you do, pop them in the chat box. Chris will bring them up. I'll answer them and we'll go back. Actually, while you're at it, hit the like button. If you're not a subscriber, subscribe, hit the bell. And I know it takes about 60 seconds from the time I speak till the time you guys hear me. So Marjan, what is type 3 for disaster recovery? Excellent. Type 3 is when you've got your production environment, and in your backup environment, you've got a small environment, like a little model replica of your environment, and it's set up in an auto-scaling group. So by doing that, what'll happen is, let's say you've got your main site, and DNS is running a health check to your main site, and it's sending all the traffic to your main site. This actually goes away, and your traffic gets rediverted to the backup site. Now, in type 3, which is the pilot light, the traffic goes over here. Now, DNS redirects your traffic. Now, let's say here in your other cloud, you've got 10 servers with 128 cores. Now, here you've got 2 servers with 128 cores. They're going to have to scale out. They're going to have to add more instances. So type 3 disaster recovery is running a full operational version. And by doing that, running a full operational version, but it's small. So what's going to happen is auto scaling is going to bring it up and erase it. So pilot light, go to your primary thing, traffic doesn't work, it comes to your new cloud, and then auto scaling will raise it. So that's what you're talking about. Jazz, I'm not exactly sure what you mean by center of excellence, because every company has one. And what I mean by that is as following. If you go to Cisco, they'll have a center of excellence, and what they really are they have people like me that are, generally speaking, really, really, really experienced principal and distinguished architects, people like me that have access to the CEOs of our company, people like me that can go to the engineering team and say, I need you to code this stuff right now. Those are the kind of things that we're typically talking about. So that's typically what the center of excellence is. We're talking about, typically speaking, some people that are specialized that can make sure the customers do the right thing. But every company has one, and they're all just a little bit different. Chris, you want to bring in the next one? Ronald. So we shouldn't use proprietary services cloud if the app is very valuable. That's up to you, Ronald. I try never to use proprietary services. Here's the reason. You use a proprietary service and you're stuck. You can't get out. So unless there's a proprietary service that does something so much better than the open standard, I'm never going to use it. And my customers aren't going to be very happy with it either, because they know better. Customers don't like being locked in. Vendors have tried 1,000,001 ways to lock people in, and customers don't like it. So your future as a cloud architect is based upon your ability to advise and transform your customers. All leadership stuff. How do you transform your customers? And you got to speak their language. And most CEOs are concerned with business continuity planning. Do you know what I worry about? I'm a CEO. I worry about right now. I've been home with the flu for 3 weeks, and there was a week where I couldn't even breathe. And I was worried if I went to the hospital and couldn't breathe, who was going to teach my students? That was my biggest concern. What happens if something happens to me? Who's going to take care of my students? Now, on the cloud, if I go to the cloud and the cloud provider doesn't like me and they kick me out like one of the cloud providers did, they can put me out of business. And a cloud provider has put somebody out of business in the past. And this cloud provider was using a single cloud and a vendor proprietary service. Cloud provider didn't like them. They kicked them out of their cloud, and the company was bankrupt in a minute. So I've spoken to about 300 CEOs since then. I don't know a single CEO that's ever willing to be on a single cloud since then or use any proprietary services because they want to know they can run as fast as possible if they have to. So it's up to you. But we architects, we're not the builders, we're the designers. We start out with those executives, we ask them their business, their legal, the technical, the regulatory requirements, and then we design a solution and transform their business. And then we hand it to a team of cloud engineers to build it. I'm not selling anything to anybody that's vendor proprietary and not in their best interest. So these are one of those things that I really am concerned about. So I give my customers options. I don't lock my customers in, and I don't see any reason to use a proprietary service because if we do, they're locked in and they're stuck. So that's why I don't do it. But it's up to you as the architect. You'll have to determine if there's a good rationale to do it. And if there is, like Netflix, might be worth it. But otherwise, it's not too often. Chris, you want to bring in the next question? Joshua, are the DR types you described as cold and warm and hot and redundant? Yes, they are, Joshua. But you see, here's the thing with me, Joshua. I don't use industrial jargon ever. So Joshua, I had a really excellent executive coach. Her name was Frances. And I had just finished my MBA program. I had given a speech to about 50 CEOs. And I had my executive coach, Frances, in there. And I mentioned every buzzword, every kind of thing that you could possibly imagine. And I was all excited. Of course, when I looked at the CEOs in the room, they kind of were staring at me. And I asked my friend, who's an executive coach, who's one of my closest friends in the world. And I said, Frances, what'd you think? She took a deep breath, which is not something she does too often. And she says to me, Michael, would you mind if I sent you a book? And I said, sure. And the book comes, and the book is called Why Business People Speak Like Idiots. And it talked about how business people make up terms like PaaS and SaaS, elastic. And in the end, we talk to our customers, and with these jargon and the terms, the customers don't even know what we are talking about. And then it turns the customers off. So Joshua, you are right. You could call it cold and warm and pilot, but to me, it's backup with synchronized databases, small instances running with auto scaling, complete backup, and complete hot standby. So to me, they're that. But yes, we're talking about the same things. I try to keep everything at the CEO level communication because that's where I do my work as an architect. So I try and stay higher level for those reasons. Chris, you want to bring in the next question? And Ronaldo, I'll answer your question very shortly because it's an important one. Jamal ABD, do we need 2 network load balancers in the data center? One for web servers and one for database servers? Jamal, you will need a network load balancer for your application servers if you have more than one, and you will need a network load balancer for your web servers, but we don't use load balancers for databases. For databases, if it's a NoSQL database, we partition the database. If it's a relational database, like an SQL database, we will add read replicas, we will add caching, we will add queuing. And there is the potential to partition the database too, but when I speak to database engineers and architects, they don't love using that. But those are the means that we can use to use them. So we don't use load balancers for databases. They have their own clustering mechanisms. Chris, do you want to bring in the next one? Ronaldo, you always say learn cloud, but how can you? Because the courses are for different cloud providers. So you learn the basics of all of them, focus or learn. So Ronaldo, we don't teach our course like that. We teach our people how to design cloud architectures, and we always teach the way we did today. So Ronaldo, I think we have to talk about the difference between cloud architect training and certification training. AWS certification training is the name of the AWS service like S3 and how to configure it. But the problem is, Ronaldo, we're architects, we don't configure. we design. So realistically speaking, when we're talking about taking solution architect training, it's 3% better than worthless for us because it's teaching us the name of a service and how to configure it. Now, I have to go talk to a CEO and ask them about their business and talk about how to improve their business performance. And I've got to ask them about their revenue, their expenses, their EBITDA, their employee productivity per employee. This is what I have to talk about. And I have to talk about what are their competitors doing and what are their goals. I can't say, hey, Mr. CEO, let's learn about S3. Now, I can talk to that team and say, we can use the type of storage called object storage, which has metadata, which will enable you to find information quickly, aggregate that information, and even be able to make better business decisions. And they're going to say, this is great. But if I say S3, I've got two heads. So, Ronaldo, the way we train it is we train the tech just like we've done today. Note, virtual machine. Now, after that, I did look at a cheat sheet and saw that it was called an Azure virtual machine versus a Google Compute Engine versus an EC2 instance. I mean, I know them on my mind, but otherwise I would look at a chart. But if you actually were to take like a CCNP data center course, you'd learn all of this because the Cisco stuff teaches you design. The solution architect courses really should be junior implementation engineer training because they're not related to what we do. So you could train with us, Ronaldo, and we would teach you multi-cloud every day, just like what we're doing today. Or you could go to Cisco and learn about networking. Then after Cisco, you could go to another organization and learn about data center. Then you could go to another organization and learn architectural design. Another organization that's, how do you give these presentations? Or you could train with us. We've got a relatively very low cost program for what we do. But that's the key. Make sure you learn the network and the data center. Don't learn the cloud stuff. Learn the network and the data center. What do we do as architects? We take things from the network and the data center and we move them to the cloud. What is the cloud? It's another network and a data center. As long as you remember the cloud is just a network and a data center, you'll always know what to do. So learn the network and the data center. Then you'll have the technical competency to wow any hiring manager and get hired every single time. That's how I teach my students. And on Saturday, you're going to hear from my student, Yvonne, who's 24 years old, just got hired by AWS, hasn't even finished school yet, never worked in tech a day in his life, but he's hardworking, he's energetic, he's motivated, he's enthusiastic, and he's got a personality like you wouldn't believe. And AWS loved it. And he went there and he gave his interview presentation. He talked about virtual machines and load balancers and things. He showed them architecture. He showed them a security architecture like this, and they shut it down. They said, okay, we get it. So learn the tech. Always communicate what the tech is, not in terms of proprietary services, and the world will think so much differently of you. It made a difference for me. Derek Houston explained type 2 disaster recovery. You got it. So Derek, imagine this. If type 1 is you take everything that we have and we just back it up and store a copy of it somewhere else, good. But type 2 is that same environment. I take all the Go Cloud Architect assets and I copy it and stick it in S3 in case I ever need to launch it. But type 2 is I've got a MySQL database that I'm running here that keeps track of transactions, and I synchronize it to the cloud so that our databases are always synchronized so I never have stale or old data. Otherwise, it's the same as just backup there. Great, great, great question. Ahmed, this is probably rare, but what if all three clouds fail? Well, if all three clouds fail, we're still okay because we've got our own Openstack cloud. But if you're dealing with more than two clouds failing at the same time, we have a problem. Because these service providers are really good. We can make fun of AWS for making up terms like impaired network device, which is a ridiculous term, but they've got really rock solid people building their systems. Facebook has really rock solid people. I know network engineers at Facebook that are earning well over $500,000 in a year just as a network engineer because they're that good. And they still have outages. Azure has smart people there. So it's not how good these people are. I want you to understand this. These cloud providers are really, really good. They have really robust infrastructures, but common network fails, things go down. So kind of keep them. So if that happens, Ahmed, I think we've got another bigger issue. If multiple clouds are going down, like all three, we probably had an electromagnetic pulse or a nuclear war or a major, major, major disaster that is going to be a real concern. And then I don't think we're going to be too concerned about tech at that point. But it is feasible. What other questions do we have, Chris? Jan Frank, how do you solve the data replication and recovery synchrony between different cloud providers? Jan, there's nothing to do. If you've got two databases in the same data center, they can synchronize. And now we've got IP connectivity to all three of them. So because we're using Cassandra or MongoDB, they've got their own database synchronization. And they're just gonna do it over the highly robust network that we built. IP connectivity, single network, they replicate. Now, if we were using DynamoDB and Cosmos, this would be a disaster. But for what we're doing, I think we don't have to worry about these kind of things. Great question there, Jan. Chris, you want to bring in the next one? Ronald, you have the CCNA certification. Excellent. And we'll do the solution architect exam in less than a week. What do I suggest next? Okay, that's a reasonable question. So Ronaldo, I don't know your background. So that really, if you tell me your background, I'll give you some better advice. So the question becomes is, have you ever interviewed a CEO before? Have you ever done an ROI model? Have you ever done a presentation in front of 5,000 people? Have you ever written a document for the CEO? Have you ever sold something over $1 million? Have you ever managed a team of more than 20 people? Those are the skills that I'm concerned about for you being an architect, and you need to learn them. So if you have the CCNA and you do the AWS Certified Solution Architect Associate next week, probably the next thing to do would be the AWS Certified Solution Architect Professional. And then after that, I would do the CCNP. Now, Ronaldo, I want to be very clear. That's not enough to get a cloud architect job. That will give you some of the technical competency, but that is engineering competency, not architecture competency. So you will need to do the following. You could train with us, and we've got a very inexpensive program that will teach you. If you are not with us, which is totally fine, make sure you do the following. Make sure you take a presentation skills class. Speakeasy in California does it. It's a 3-day class. It's about $3,000. It's a good intro to presentation class. Make sure you take an emotional intelligence class. Again, we cover all of this, but if you're not with us, go to Goldman and one of those groups. For about $5,000, you can get an emotional intelligence class. Now, you have to learn how to do executive writing. So take an MBA, go and find an executive writing class in an MBA program, or read about executive writing, or take a course like ours. Now, you're gonna have to do proof of concepts, Ronaldo. And when you do a proof of concept test, you're not gonna be building it. Your engineers are gonna be building it. So you're gonna have to lead a team of about 20 engineers to do a proof of concept, which means you're gonna have to have a lot of leadership skills. Now, when you're an architect like me, and you need to get those, 20 people to work for you, you have to go to the people's managers and justify why you're taking them. Because if you borrow somebody's employee, that person's not getting their work done, which means their manager's not going to like them. So you're going to have the skill to go sell other managers across your organization to why they need to give you people. So that means you're going to need to reach out to managers, directors, VPs, SVPs, all the way to the CEO. So that's really great. Now, the fact that you just graduated with telecommunications engineering means you've not done these things. So you have two choices. The two things, if you do the Certified Solution Architect Professional and the CCNP, that would qualify you as a cloud engineer, which is great. But if you want to become a cloud architect, you're going to need those leadership skills that we're talking about, because we are business transformation specialists, not engineers. So the architect thing is not about the technical piece. It's about the business piece. Note most of the things that I discussed today. Vendor neutrality, availability. What happens if systems go down? None of that's tech. Now, I did get kind of geeky when I talked about multiple power supplies, line cards, internet connections, BGP, OSPF. Yes, you got to have that. But it's a 50% tech job and it's a 50% non-tech job. So please make sure that to get to your goals, you've got at least 50% of your time training in the non-technical things. This is not an engineering job. This is an architecture job. This is a sales job, a business job, and they're very, very different. Keep that in mind. So Ronaldo, I got to tell you, when it comes to me getting people hired, if I've got somebody that's got 30 certifications on their resume and they want to be a cloud architect, I remove some of them. If someone talks about all their coding and building, we have to tune it and remove it and change it to the transformation, the net output for the customer, the business impact. So keep in mind that engineering and architectures are so different. And that when you start talking to a lot of certifications, you're talking about engineering. I need the architect to be a cross between a CCIE level network architect and a business executive. That's what we're talking about. Chris, do you want to bring in the next one? Jan Frank, question. How do you solve the database replication and synchronization? By providing network connectivity between it. And that's just a part of the way databases work. So we don't have anything to worry about like that. Chris, you want to bring in the next one? I might be doing pretty good answering these questions at a relatively good speed, which is usually faster than me, Chris. Noel, in terms of cost benefit, is it generally preferable at cheaper long-term to have a hybrid environment or a public multi-cloud? I prefer the hybrid cloud environment far more. And here's the reason. It depends upon how good you are. And let me explain this to you. So I've got a cloud. And I bought 10 servers for $1,300. These 10 servers all have 4 cores, 128 gigs of RAM, and NVMe RAID arrays. I'm running 478 students off of my cloud 24 hours a day, 7 days a week, including all of my computer workload, and my systems operate at 30%. Which means for 1 year, I've spent $10,000 and another $1,500 on electricity. Now, I can probably run that for 5 years and service all of my students. Now, what would one of these things cost on the cloud? Several dollars per hour. As opposed to, $10,000 one time. So if you're really good at operating your data center, it's going to be cheaper. But the agility isn't there. So how does AWS do it? They build a network and they build a data center. They operate it and they make money. Does that mean you can build your network and data center and then charge 30, 40, 50% margin and still make money? Yes. So Noel, I'm a landlord. I buy a house that costs me $1,200 a month. I charge you $2,000 a month to rent my property. I have to make money on you. So the second you go to the cloud, you have a cloud provider that's reselling you services, which means they've got to charge more than it costs them. So if you're really good, you can run your own cloud much cheaper than the cloud. Now, Noel, where is the cloud cheaper? Because in some cases, it's dramatically cheaper. Let's look at where the cloud provides value. So I've got a big application that's running in my data center on servers that I paid for once. Cheaper. On the cloud, I've got a web application. Whoa, stick that on the cloud. Why? In the data center, what's the busiest shopping day of the year? It's Black Friday. So I architect for Black Friday. I say on Black Friday, I'm going to get 1 million orders per second. I'm going to add what they call a fudge factor. So I'm going to add like 50% more because, whatever we think it is, double it. So I'm going to build for 2 million transactions per second on my data center. Now on the cloud, I might only have 50,000 transactions per second all year and 1 million transactions per second during Christmas. On the cloud all year long, I pay a higher price for my 50,000 transactions per second. So instead of that costing me $1,000, it cost me $1,500. But I'm paying more for less, but I'm only paying $1,500 instead of maybe a few $100,000 for that website. Now, Black Friday comes around 3 days in advance. I launch more instances. I pre-run my load balancers. I've got the capacity for Christmas. Christmas is over. I shut it down. I go back to my cheap capacity. So the auto scaling of the cloud provides a level of cheapness and agility that's amazing. Let's also talk about where the cloud gets cost. Okay, we talked about a lot of networking today. A lot. How expensive do you think the networking people like me are that can actually do those kind of networks? Well, first, let's assume there's 1,000 of us in the entire world, and that's it. How expensive do you think we are? Very. It took me 75,000 pages of reading to become a CCIE, 500 pages of reading to become a AWS Certified Solution Architect Professional, about 500 for the Azure Expert, and about 400 for the Google Professional Cloud Architect versus the 75,000 pages for the CCIE. Who's really more expensive? Who are you paying more? You're paying much more to the networking people. Why? Because the complexity is so critical. So now, Noel, I also want you to think about this. Now, I've got me and my environment. I want to connect to 1,000 other organizations. Okay. On the cloud, they're all already on AWS. VPC pairing, private link, it's done. I want to build it on my own. What do I need? I need a router at my end and a router at the remote end for all 3,000 locations. Ew. So by being on the cloud, there's no equipment to purchase that's cheaper. So Noel, some things are much, much cheaper on the cloud and other things are much more expensive on the cloud. So when it comes down to it, it's all a matter of deploying the right thing at the right time. And it's for you, the architect, to do the ROI model, to do the calculations, and then advise your customer, where should you be? Sometimes people come to me and ask for a cloud, and I say, that's great. I'd love to build it for you, but you got all this unlimited server capacity. What if we build you an Openstack Ansible cloud in your facility, and we give you all the benefits of cloud computing, and you don't spend a dime? And they're like, really? And I say, yeah. Other customers that I have data centers that were designed so poorly that we have to start from the beginning and rebuild it. And I would suggest stick it all in the cloud. So all of this is based upon the analysis. So Noel, the bigger question I have for you is not what's cheaper. The bigger question I have for you is which does a better job. So, people have it in their minds that customers have a budget and they're going to stick to a budget. Like a business buys tech, like we would buy a car and say, okay, I can afford this $500 car payment, I'm buying the car, and if I can, I'm not doing it. That's a depreciating asset. Now, I want you to really think about this. Let's say we've got a healthcare delivery system. Let's say they're big, like an Extension or a Catholic Health East or an HCA or a Tenet, somebody that's got 50 or 100 hospitals. I just want you to think about it for a minute, to really look at it, because I want you to think about the job of the architect, because it's not as an engineer. Now, I go meet with the CEO of one of these big healthcare organizations, and I say, Mr. or Mrs. CEO, tell me about your business. And they say, Mike, we're struggling. COVID came in, and we're not doing the elective procedures we have. And the COVID patients don't pay compared to our elective procedures, and we're struggling. Last year, we did $1.8 billion of revenue. This year, we've done $1.2 billion of revenue, and we are really struggling. Patients are afraid to come to the hospital, so they're ignoring preventative care, and when they finally get to the hospital, they just die. Now, I heard this, right? The CEO says two things. Revenues are down, and people are afraid to get prevention or primary care, and because of that, they're not coming in, and people are dying. This is a bad situation. So what can I do? What are my questions going to be? Mrs. CEO, tell me what's going on in your organization. Are your people doing a lot of overtime? Oh my God, Mike, do you know we employ 50,000 nurses in our organization that have all been working 2 hours of overtime because we fired some people because they didn't get an immunization? Wait, you have shorter staff? Yeah, we have less staff. We had to fire people, and we're losing money, and we're paying overtime all day, every day. And then I say, okay, did you tell me you have 50,000 nurses? Yes. What's your fully loaded salary for your average nurse? And they say $56 an hour, including benefits. And I say, okay. And I say, how many hours on average are your nurses working? And they say 2 hours of overtime. And I say, overtime is time and a half, right? And they say, yes. So I take 56, and I take 56 times 2, 56 times 1.5, because that gets us our hourly rate, which is $84 an hour. And we know that each employee is doing 2 hours of overtime times 50,000 employees. Oops, I did that. So let's say 84 times 2, 84 times 2, which is 168 per nurse per day times 50,000. We know that we have an $8.4 million problem right here. Just that is an $8.4 million problem. Now, if we know that's an $8.4 million problem, if I can come up with a solution to that CEO that costs $4 million, that's going to save him $8 million or her $8 million of overtime every year, is it a good solution? Yes. So let's say we build a data center. It costs $4 million and it saves them $8.4 million every year. They keep the tech for 3 years. That's $25 million we saved them and they paid for. Is it a good investment? Yes. So Noel, I don't generally look at what the people tell me in terms of budget. I can create budget out of nothing. That's why I do my ROI modeling. I look at the problem. I look at the value of the problem and I craft a technology solution that costs much less than the fix. That's architecture. Now, you didn't hear me ask a lot of technical questions to that CEO. I wasn't asking them what their S3 buckets look like. I wasn't asking them about their IAM policy right here. I'm trying to find my end state. What is it that solves that customer problem? What is it that gives that customer a competitive advantage over its other customers? That's what we do as an architect. So, the ROI. So, why is business acumen so important? Well, if you can't ask the CEO those questions, you don't have an architecture. Nobody hands you a piece of paper that says, build this. You got to start with the customer. What do you want? Okay, so let's talk innovation. We're talking architecture. Let's talk innovation. Let's say I want to design a new anything. How do we do it? Let's say right now, all of you are going to design the next cloud. We're going to all do it right now. We're going to go design the cloud of the future. Every one of us. In there, in the chat box, type something cool that you think the cloud of the future should have. Every one of you, got 85 people right now. All 85 of you in the chat box, tell me what this new fancy cloud should have. Some awesome feature. Because we're going to build it right now. If you want, I'll design it and I'll show you how you design the solution by starting with the end goal and working your back. Okay, so speed. Crypto. Crypto and cloud is generally two things that don't go together. And the reason, although we talk about it, the reason it tends not to be is as follows. Crypto or blockchain is about distributed computing and cloud is about centralized computing. So we're going to put auto scaling in there. We're going to make it really fast. Maybe we'll do some blockchain in there. Sure, while we're at it. Oh, come on, let's add some fun stuff to it, everybody. Okay, all I got is some blockchain and really, really fast. Okay, we're going to build the world's fastest cloud right now. So let's do it. So.
You got something decentralized.
Yeah, the very nature of a cloud is it has to be central.
Yeah, right.
But you know what? Cats, I love the concept of cats. I think we should have cats everywhere as mascots, making sure there's no mice going through the things. We're going to have some streaming data. Yeah, okay, awesome. Okay, so we're going to build the world's fastest cloud. You guys weren't super creative in coming up with lots of things, so we're building the world's fastest cloud. And it's going to be really, really Alonzo like smart home. Okay, you know what? Let's design a smart home, and then we'll figure out what cloud it can be. Alonzo, great suggestion. So we're going to design the smart home of the future. So what do you want, Alonzo, in this smart home? You made it. Yeah, Alonzo, you're an extremely good friend of mine. What do we want in the smart home? We want special high-grade security, right? We want to do some cat filming from Marla because we've got a special cat named Cindy, and we want to create Cindy cat calendars. We're going to take this house and we're going to make sure that you can turn on the TV with your phone. We're going to make sure that on your phone you can talk. Yeah, that's my cat, Cindy. She's a sweet, loving, wonderful girl. She sleeps in between my knees every night, and she's one of my closest friends. So that's my Cindy, and that's why I'm usually sneezing. But that's neither here nor there. Look at that face. So we've got this thing. Okay, so now let's talk about it. So let's take this house that Alonzo wanted us to make a smart home. Temperature, security, and lighting. So what are we concerned about? Temperature and security and lighting. So let's put over here, temperature. Thank you, Jazz, and you're more than welcome, Cindy. And we've got voice. So Alonzo says temperature, security, and thank you all, my kitty cat. So you said temperature, security, and you said lighting. And okay, so Alonzo, you said temperature, security, and lighting. Alonzo, you're the CEO today of your new dream smart home house company. So, and you said a voice app. Excellent. How much security are we concerned about? What are you protecting, Alonzo? Are you protecting something life-threatening, or are you protecting? You just want a notification that says someone is knocking at the front door. The first thing we need to understand is the critical nature of it. So on the temperature side, are we in Alaska, or are we in an environment where if the air conditioner fails, nobody dies? So we need to know that. Now on the security side, Alonzo, we need to know what happens if you get anybody breaking into your house. If somebody breaks into your house, if it has a lethal consequence to you or your family members, I need to know. If you're protecting something critical for the government, I need to know. So I need to know about your security component. Now you mentioned lighting. I need to know what your lighting goals are. Is it when you walk in the room, the lights come on, or do you need specialty lighting for photography, videography? Now, you also mentioned a voice app. What do you want to do with the voice app? Are you trying to control things? Are you turning on the TV? Or do you want to have like a basic conversation with someone? That's what we first need to know. So now, if we are in Antarctica, how important is the temperature control, everybody? If we're in Antarctica and our heaters fail, what happens to the people inside, everybody? Are they happy? Or do they turn into popsicles? Okay, so it's mission critical to the heaters. Now, Alonzo just retired from the Navy SEALs. He was a sniper in the Navy SEALs, and he's been a sniper for 20 years in the SEAL teams. Alonzo has enemies. There's a lot of people throughout the world that want to come after him. How important is the security now? Okay. Now, we are concerned about the lighting in this house for whatever reason. So, is the lighting critical or not? Well, maybe it depends. If we want to use the lighting in a tactical situation because Alonzo has people that want to go after him, and we've got light bulbs and he can shine a light to temporarily create some space and blind people, then the lighting is critical. Or does he just want to walk in the rooms and make the room be lighter? These are the kind of things. So Alonzo just told us he's a government leader in need of secure environment to store critical files. So if these files get taken, somebody will die. So what level of security do we need for Alonzo? A lot. A lot. Now, let's talk about his voice goals. What does he need to be able to do? Is it, hey, Siri, I want turmeric tea? Or is it something very, very special? Okay, now we're dealing with Alonzo. He needs specialty environment lighting. So we're talking about something very cool. So now let's think about this. Are our needs basic or are they serious? They're serious. So first we have to start with the end goal. Now, if Alonzo works for the government and has very valuable information that people want to steal, do we think we're just going to turn him online and connect him to the internet, or do we need some special security? We're going to need some special security. So for Alonzo, are we going to need an enterprise-grade firewall? Yes. Are we going to need an enterprise-grade IDS IPS system? Yes. Are we going to be using access control lists, secure? Yes. Are we going to be using host-based firewalls on the systems in his house? The answer is yes, because they're mission critical. Now, Alonzo said, I want a smart home. I want to be able to clap and turn on the TV. Now, am I getting an enterprise-grade firewall? No. Am I using any of these other things? Of course I am not, because it's no longer critical. So what drives your architecture? The requirements. Alonzo's the CEO, works for a government. He told me he needs voice activation and encryption for his home-based tech. All this matters. So should we use wireless in Alonzo's house, or should we hardwire everything? Hardwire. So is there anything we can do to the switches to make sure that if the wrong person plugs in their computer, they won't be taken online? Yes. We can enable 802.1x authentication, which will shut down all switch ports. So we've disabled the wireless in his house, and we've hardwired everything in 10 gig Ethernet. We've got military-grade firewalls for the security. Now, what happens if somebody breaks in? Do we have a problem? Yes. Could we come up with a camera outside? Could we tie that camera to a weapon or a weapon system that could potentially take out a threat? The answer is yes. Now, if we had something like this, how precision does it need to be? Very. Because if we have a weapon system for defense and it does something to the wrong person, we've got a problem. So that again means ultra critical security, ultra critical availability. So let's start thinking about that. Now the lighting is critical and the voice is critical. So in this particular environment, we need a lot of tech. And because of this, the tech's going to drive our architecture. So what's this going to look like? Well, we need a firewall. Let's look at our systems. From the security perspective, we're going to need a firewall. We don't need a content delivery network, right? Because we're not serving any websites. Okay, so behind the firewall, maybe it has an IDS IPS. Let's just put it here for right now. Now we're going to put some routers in Alonzo's house. Should we put an access control list on them? Of course we will. Now we're going to have a couple of servers in his house that are going to store this stuff. So are we going to do security by obscurity or not? Now we can take a Windows system or a Linux system. Let's face it, Windows systems are amazing, and I'm a Linux user, but let's think about how amazing Windows is. It works across every hardware platform in the world, and it supports 1,000,001 devices. Pretty incredible. Now, let's look at the downside of being able to support 10 million different kinds of devices. So you can't control the drivers, which means you can't control the accuracy and the quality. So now, look at these requirements that Alonzo's got. Real-time data streaming for resense against terrorism. So we've got a lot of things. So let's talk about how we put this together. So we've got his servers over here, right? And we've locked it down. Now on these servers, we'll make them Linux because they're more obscure. There's less tools to hack Linux. It's not that it's more secure, but there's less tools. So we've got some Linux servers. Anything can get hacked. We've got some Linux servers. Now, would you put internet connectivity in Alonzo's home? Does he need it? Maybe, maybe not. If he doesn't need internet connectivity, don't give him internet connectivity. Keep it a private network. But let's assume he did, so we'll put a firewall. Now on these temperature sensors, what do they need? They have to work, right? So they need a network that's going to work. So we need an HA network or a high availability network. Oh, wait, I showed you how to design that an hour ago. Now security. Alonzo catches terrorists. These are bad people. So he needs security. So do we think we need physical security? Yes. keeping the doors locked, maybe some guards. So we need physical security. We need cyber security, right? The stuff we've already done. Do we need any kind of humans or other defense along the way? Maybe we hire some executive protection. We hire some retired SEALs, some Israeli commandos, some SAS commandos. So we've got people security. Okay, so now we've got some of that. What about all this lighting stuff? What's the lighting going to need? Well, it's going to need a network to work, right? Back to the high availability network. Do we need any special lighting here? Do we need any special temperature lighting? Does it have to be daylight? Can it be soft white? Are we using a certain kind of strobe to disorient attackers? What do we need? Well, we got to figure that out. So we need to know that, but we're definitely going to need a light bulb, and we might need some special light. We might need some special type of lighting technology. Okay, now for the voice. He wants voice-enabled everything. So how do we make voice-enabled work better? Are there any technologies that are out there that can recognize languages? And anything we can do there? Let's think about that. Also, Randy, it's something very interesting. So according to the FBI, the average violent attack happens within 3 seconds and within 3 shots. So you dial 911, you hit a dispatch center. The dispatcher speaks to you for about 2 minutes to get the information, and then call the police car. The police car on average is 3 to 6 minutes away. So it takes 2 minutes to place the phone call. In the dispatch, about 1 to 2 minutes to dispatch it to the police officer, and another 5 to 6 minutes to get it away. Is that fast enough? I mean, the police officer will be able to write up the report when it's done, but they're not going to be able to act fast enough. And it's not because our law enforcement aren't incredible. I come from that background. I come from the paramedic background. But the point is we need something fast. So regular house, no big deal. Guy that works for the government, top secret information is going to need better and faster. But we're not going to get away with an ADT kind of security. We're going to need something much, much, much better. Maybe we're going to need a direct line to the CIA or the FBI. We're going to need something strong and fast. We want SWAT coming. We want something different. I've trained a lot of SWAT guys in Krav Maga and some other types of things. We need something fast. So what kind of network is that? We need specialty security. So just keep that in mind. Now, the next part is on the voice side. We need a secure voice environment. Might we need encryption for the kind of calls that Alonzo's doing? Yes. Might we need privacy? Sure. Might we need to know that nobody else is on the line? Sure. You know, would it even make sense for us to build our own private PBX environment, our own phone switch, so we have ultimate control over what goes down? Yeah. So we might even need some special telephony work. Now we can figure out the tech in a minute. Okay, so this is our architecture. This is our end state. This is the desired state. Note, we haven't even thought about tech yet. This is our desired state. What is it? This is a business architecture. Okay, so now let's think about it. So let's go design this. So let's take a security architecture, like I'll bring in a security architecture. Let's design a security architecture. I'll pop one in. I'll use my standard security architecture. We'll modify it. I'll show you where that would be. So let's take a basic security architecture. Now we're not using a CDN. Why? Because we've got no web apps. It's in his house. So do we need a network load balancer? No. What I would probably do if it's in his house, I would set it up this way. I would use a Palo Alto firewall. I would use a network access control list. And on the servers, I would use a host-based firewall. That's going to lock us down pretty strong. Now, this is the cybersecurity architecture. Okay. What about the physical security architecture? Well, it goes there. Okay, so now let's look at the physical security for our good friend Alonzo. What kind of door do we have? We're going to use a cheap door or a big door? We're going to use a big, heavy steel door. So, big, heavy steel doors. Oh, Derek, you're starting to get there. Steel door. Now, before we get to the house, we're going to have a fence. Exactly. So we're going to have a fence. Now you guys are thinking like architects. And really, the reason I want to walk through this with you, I don't care what you're designing, the process is the same. So just so you know, when I work as a business architect, I do this. When I work as a management consultant, I do this. And when I work as a cloud architect, I do the same thing. Okay, so now we're going to have a fence. We're going to have a steel door. Now the house. Somebody could shoot through the house, right? So let's make the house not shootable. Now, we can't protect against everything, but let's look at the kind of small arms that people typically have. Can we protect against a 7.62 by 5.1 round? Yes. Can we protect against a 300 Win Mag round? Yes. Can we protect against a 338 Lapua round? Yes. So maybe we have a big, hard, concrete-filled cinder block house that's got steel behind it, so it's bulletproof against common rifle attacks. We may even choose to go against anti-personnel machine guns like a 50 caliber BMG, but the point is we have to build for what we're looking for. I don't know. Alonzo is my customer. Alonzo is military grade. He's going to tell me what kind of protection he wants. He will tell me, literally speaking, the kind of bulletproof that we need. We will use Lex and windows that are bulletproof, that will deal with a rifle bullet, not a pistol bullet. We will have steel doors, and we will have a bulletproof environment. Yes, we absolutely will. Now, should we get Alonzo a German Shepherd or a specifically trained dog? I would. We'll get him a canine. I would. Now, does Alonzo need any special security training? Sure he does. We're going to assume he has it, but if he doesn't, I'm going to train him in Krav Maga. Like I've trained lots of SWAT guys and other people. I'm going to train him in Krav Maga. What else? I'm going to put a safe room in this house. And what's going to determine how far do we keep going? The threats against Alonzo. He's a Navy SEAL sniper. The world's out to get him because he took a lot of bad people out. So, we got to build around it. So we need him. So you know what? Maybe we build him a bunker too. We've got a safe room, but maybe we build him some tunnels to get out of the house. What drove this? Millicent, you said weapons? Sure. Let's give Alonzo some body armor that will handle a rifle. So it's got trauma plates. We'll give him some body armor. What do you want to give him? You want to give him weapons? Okay, so let's give him some edged weapons. And he worked for the U.S. government. He's a Navy SEAL. Manolis would be the perfect kind of dog on there versus the German Shepherd. Perfect. I have a friend that raises them. Okay, so we've got some body armor, some edge weapons. The government told us he's authorized to carry a firearm, so we'll give him a firearm. Now, if the requirements were different, we use different things. Again, I don't care what you choose. You're the architect, but you've got to ask your clients. They're going to tell you what they want. We're building to what they want. Now, none of this is tech, but is a critical part of our architecture. Sure it is, because without this, bad stuff's going to happen. So now there's physical architecture. Now, why shouldn't we use wireless? Wireless broadcast signals out, huh? Signal. Could you? Yeah, we'll keep some of those nasty MREs in the foam millicent. You're right. We'll have MREs in there. We'll have a gas mask in case someone wants to gas them out. We're going to take care of all these kind of things. You know what? In that safe room, maybe we'll have some scuba tanks, and we'll also have a tank of water in case somebody wants to smoke them out. Now we've got a security architecture of the firewalls, access control lists. Okay, so now let's build a network. What's our network have to do? Well, can we allow, our network needs physical security, so let's go look at the network. So are we going to leave our routers and switches any place where people can reach them? No, because if you can plug into the network, guess what? You're on. You've just hacked into us with nothing. So where do you think we might put the network? In a steel enclosed room? With metal doors? That's impenetrable? Redundant power coming into that? Redundant cooling coming into it? Generators? UPS systems? And backups? Are we going to have that? Yes. If the tech goes down in his house, are we in trouble? Yes. So backup generators as well. So now we've got the security. Now let's look at this network. This network is going to be fine, really fine. We've got that safe room. So, somebody is going to have to breach a fence, a steel door, the canines, Alonzo and his excellent Krav Maga skills. He can hang out in the safe room. He's got tunnels to get out of the house if he needs to. He's armed with body armor, edge weapons, and firearms. I think he's pretty good in his safe room. Now the network. How important is the network now that we've deployed all this? We've got all this electrical stuff. Now what happens if the network goes down? We got problems. So what kind of networking do we need? Are we using cheap $5,000 routers? Or are we back into these $100,000 routers with multiple line cards and control modules? Yes. We're back into very high availability systems. So we've got HA routers. Now, do you think we have one of each or do we have two of each? Two of each. So big routers, high grade. Now, the routers are locked up. So let's say this is going to be let's call this first locked room. Now we've got our HA routers. We need them. Okay. Now, the routers are going to do the routing between subnets, but where does our stuff get plugged in? It gets plugged into a switch. So we're going to need some HA switches, which are basically multiple line cards, power supplies, etc. Okay, now, what happens if you plug into the wrong port? You got a problem, right? So somebody sneaks into Alonzo's house when he's not looking, and they plug in to a port, and the port shuts down. Did they get access to the system? No. So I typically use some kind of MAC address authentication. It's called 802.1x in everything I do. Now, we've got 5 servers plugged into a switch. They're all in the same VLAN. Now, they're in the same VLAN, which means the same broadcast domain. I just got infected by a virus. Poof, I'm infected now. So if I've got 5 servers in the VLAN, all 5 servers get infected. Is there anything that I can do to further lock that down, which you could never do in the cloud, which you can do in the network in the data center? Yes. I'm going to run a private VLAN, which means that if I've got 5 servers in the same VLAN and one gets infected, it can't infect anybody else because they can't talk to each other in the same VLAN. Oh, wait, doesn't a private VLAN sound like a container? 2 logically isolated things in the same environment? Yes. So I'm going to run private VLANs. And obviously, we can't get this secure in the cloud. So that's why we're not using the cloud. We're doing it in a data center wise, because we can't do 802.1x or private VLANs. We don't have any of this ability. Now, on the locked room, what do we need to get inside there? Should we have a key? Should we have a key that also requires a scan of his iris? We can use both. So what is that called, by the way? Those things that we're talking about, authentication. So we're going to use a form of authentication that's called something you have and something you know. So that's a multi-factor authentication. Your ATM card, something you have, which is your card, something you know, which is your PIN. Same concept. So let's just kind of keep this in mind. Just keep it in the back of your mind. So we're going to do private VLANs. Now, what about the network connections? Do we have a single one or do we need multiple? Let me know in the chat box and why. If we lose one of these connections and the connections are responsible for the whole house, do we have a problem? Yes. So what are we going to do? We're going to have redundant connections. What are they going to look like? A bunch of link aggregation groups across line cards. Now, yes, exactly, Jazz. Now, what might be some reasons Alonzo might need to get to the internet? Why might he need to get to the internet? If there's a new vulnerability tomorrow, should Alonzo be able to patch against it? Yes. Might Alonzo need to connect to the internet to do some research? Yes. Should we give Alonzo internet access for those reasons? Sure. So we need to firewall off that internet situations. Download updates, so we need that internet connection. So we can't get away without it in this particular use case. But if we didn't need to go to the internet, then we wouldn't have internet access. But we're going to firewall that off. So no wireless signals. Everything is hardwired. You've got a mountain of things to get through it just to even get in. Now, are we going to put this house? What else could we do to make this house better? Make the security environment. Could we put Alonzo's house on the top of a mountain where you've only got one way in and we've got cameras on the way in that would notice if it's during the 10-minute ride up the mountain? Could we move Alonzo to a more remote location? Sure. Would that provide an additional level of security? Yes. So we can find these kind of things. So these are the kind of things we're playing with. But we haven't done the lights yet. So let's look. We've got a couple other things that Alonzo was talking about. So we've got the security. All right, the telephony. Okay, we're going to have voice. So how are we going to do this? So what does it take to put a really nice end-to-end voice solution together? Well, you need something to control the voice calls. You need something that does the signaling, and you need to put things together. So do we want to rely on an external phone company for this? Or are we doing our own? Could we put a phone switch here and connect that phone switch maybe to a private line to his office and give him ultimate secure access to government phones? Sure, we can. So keep that in mind. We're going to be patching exactly. That's when we need the internet access. You're completely right. So good. So we've got our security architecture, our physical architecture. Now, the power architecture. Do we think Alonzo's house is going to use a lot of power? No. Yes. Do we think Alonzo's house is going to work within normal power specifications? No. It's kind of like me. Every once in a while, I find somebody outside of my house and they're walking around trying to figure out what's going on. And it's usually because I have a $3,000 a month electric bill, because there are times where I'll have 80 GPUs running calculations all day long. And, my house generates a lot of heat and a lot of electric. So until people came to my house and started saying that I had a GPU mining farm, they assumed that I was doing something else or growing something in my home. So people were constantly looking at my house until everybody got to know Mike, the guy that's got a data center in his house. So his house is going to be loud and it's going to sound like a jet engine and it's going to need a lot of power. So what are we going to have to do? to make this work? Power upgrades. Let's assume Alonzo, I know Alonzo real well. Let's assume he's in a pretty modern house. And let's say in Alonzo's really modern house, he's got a 240 volt AC and he's got 200 watts of power, which, let's really think about that. Let's go through Kirchhoff's law. Kirchhoff's law is volts times amps will determine how much power we need. Okay, so let's analyze Kirchhoff's law. So let's assume that Alonzo right now has 200 amps at 240 volts. So that's 200 times 240. That means Alonzo's house is capable of dealing with upwards of 48,000 watts. Okay, so we're going to put 4 128-core servers in his house. That's about 6,000 watts right there. We're going to put a Cisco network in there, which is going to run another 10,000 watts. We are now going to put security cameras in here. We are going to be putting AC systems in here, specialty backup cooling systems here, networking, specialty lighting. Do we think the 48,000 watts that he has for his house is anywhere close to enough? No, not even close. So what are we going to do? We're going to bring in multiple 200 watt circuits or 200 amp circuits, with multiple transformers, so that if one power to the house goes down, another one in a dedicated circuit might be second. So we're going to have diverse power. Now, if a hacker was able to cut off his power and we could lose some of the auto defenses from the house, it would be bad. So we've got power from 2 companies, but what if that goes down? It's still not enough. So what do we need? We need a generator. Do you think 1 generator is enough, or do we need 2 generators? We need 2 generators. And if we need 2 generators, what do we need? Lots and lots of fuel. So we need to make sure we have that. Where's generator? No, we've got generators. We've got a month's worth of fuel in case we've got some bad people in a hostage situation. We've got a month's worth of food in his safe house, in his safe room. He's armed. He's trained. We've got all this. So now we've got the power. Anybody think some of this lighting is going to take a lot? Okay. Do we need anything to control the lighting? Yes. We're going to need some kind of a server or some kind of a device that's going to control the lighting. So we need a server. So we've already got that under the architecture, and we've got our servers in here. So we just know we need some more servers. So pretty much we've got what we need here. Now let's go back. What else is missing? We've got the lighting. The lighting's going to be plugged into the network. The voice. The only thing that we haven't done yet is we haven't done the voice yet. So let's add some Cisco call managers over here, or phone switches, or a PBX. Okay, now we've got our own phone switch. This phone switch can determine who's around, why they're around, and what they're capable of doing. And we've got a really nice high availability architecture. So what did we do with Alonzo's environment? We asked Alonzo, what did he need? After Alonzo told us what he needed, we mapped out what our goals were, and then we backed it into the architecture. So I really want to work through that with all of you. This is the innovator's dilemma. This is the difference between an architect and an engineer. The engineer wants to build it. We don't build it. We design it. So what do? We have to go start with that source, that Alonzo. What is it that you want? Then we design the end state, and then we back in the technology. The technology is the last part of your job as an architect. That's the key. The technology is the last part of your job. So when people ask me, Mike, which certifications do I need? And I say only 2 of them, because the certifications don't teach this. This isn't part of certifications. This is architect work. I'm going to tell you this. There is no architecture certification. The closest we have is TOGAF. And that'll teach you a framework that's so theoretical you won't even know what it means. In fact, I've taken about 50 TOGAF architectures, and the customer said, Mike, what is this? And I translated into boxes like this, and they were, oh, yes, I love it. So the point is, it's got to be simple. It's got to be elegant. So let me finalize this. If you guys have some questions, let's answer them. And otherwise, enjoy your night. So Chris, let me take some questions. Also, have you guys had fun today with our multi-cloud architecture design and our cloud architecture training? If you have, let me know in the chat box. And if you've got some questions, ask me. I want you guys to have the most amazing cloud architecture careers. And I want you to understand the multi-cloud architecture reasons. I want you to understand hybrid cloud architectures. I want you to get the concept of Openstack. I just want you to know how to be a really great cloud architect, because I want you getting cloud architect jobs. And that's why I do so much cloud computing career training, and I do all this multi-cloud architecture design with you, because I want you guys to be the best cloud architects in the world. So let me tell you about some really exciting things. Very soon, we have a brand new AWS Certified Solution Architect Professional book. We took our old book, we added almost 300 pages of content to it. It is completely written. It has gone to the editors, and our team is doing the final stages, and we're going to give it out free coming very soon. So the link to register for this, Chris, I think is in the description below. Make sure you get your free copy of the book. If you order it now, you will get it as soon as it's received. So Chris, if you have a link for that, let us know. Miss Lam and John, exactly, elite designs get you cloud hired. I want you getting cloud hired. Ivo Doikia, awesome session. Thank you so much. Kin, how do you design for a group that doesn't know better much? Ask me what you mean by that. You mean, how do you design for a company that doesn't know much? Every company knows their business. You actually have to ask the right questions to the right people. And what do I mean by that is, it's pretty easy sometimes. If you speak to an engineer, they're not going to know about their business goals. They're going to know how to build it, because that's what they do. So what you're going to have to do is ask the right people. So if you're asking engineers and you don't get the information you need, go to the engineering manager. Go to the manager above that. Go to the manager's manager. I go to the CEO. I start at the CEO. It doesn't matter the size of the company. I start at the CEO. So Shiana, I wish you were here for the rest of it, but the good news is I'm going to leave this on YouTube, so you'll be able to watch the rest of it. So that's what I would do. And generally speaking, all of your customers, Karen 1, will never know much. And here's the reason why. Your audience as an architect are the business executives. They don't know technology. They don't want to know technology. If you start talking about S3 buckets to the CEO, you'll be escorted out of the room in about 15 seconds. What does the CEO care about? Increasing shareholder value in a publicly traded company. That's literally it. In fact, the CEO of a publicly traded company, if he doesn't increase the wealth of the shareholders, can be put in prison or fired. So if they make actions against the company, they can be put in prison. That's how important it is. So what does the CEO care about? Increasing shareholder value. How do they do that? They increase revenue. They decrease expenses. These are their tools. So if you're not getting the answers you need, you're asking the wrong people. So trust to ask a different set of people. But realize you're never going to get anybody that knows tech if you're asking the right questions to the right people. You're more than welcome. Sarithina, ready? Any other last minute questions for me? Otherwise, if you've had a good time, hit the like button, subscribe, hit the bell so you get informed of new things. On Saturday, we're going to have some fun on Saturday. On Saturday, let's talk about this. And also, while I tell you about Saturday, let us know where you're from in the chat box. And Lenny, and only a multi-cloud environment is preferable to just about everybody. To put it into context, a year ago, prior to a cloud provider kicking a single company out, 29% of organizations were using a single cloud. Since that time, 3% of organizations are using a single cloud. So, because of that, we know, quite frankly, that nobody wants a single cloud, because the customers are telling us they learn smarter. Every customer knows a single cloud is a single point of failure. The only people that were trying to do this is the cloud providers were saying it's not multiple data centers, multiple redundancy, but all three big clouds all had outages, affected multiple availability zones and multiple regions at the same time. It proved the concept that we told people for years. Single cloud equals single point of failure. So we've got people right now in Amsterdam and Metro Atlanta I'm looking at. I know we've got some folks in Cameroon. So let's talk about Saturday. I'm going to show you on Saturday that attitude, hard work, dedication, and learning the right things, all of you can become cloud architects tomorrow. We are going to bring in one of my students, and let me tell you, I love my students. I have students all over the world that are truly, truly amazing, but this one is a very special one. I remember this student because he popped in my call 4 months ago. I remember this young man, Yvonne. He shows up and he's in a red sweatshirt that says Georgia Tech on it. And he's in this class and he's got this smile on his face. And he's just so excited to be there. And some of my students, when they're new, they're afraid. So they have their camera shut off. He had his camera on. He was doing great. And he comes into this class and he's like, oh, Mike, I'm so excited. It's my first class. And I just remember looking at that. Well, anyway, 4 months later, he gets interviewed by AWS. He's never worked in tech in his life, but he's a hard worker, a hard studier, an expert communicator, a good leader with good business acumen because he worked on it. He goes on an interview with AWS. They stop him and they're like, okay, you know more about tech than we do. We need to just move on. So, there's that. So he's going to talk to you about how he did it. And he came to America from Cameroon at 15 years old. No background in tech. Worked so hard. He had a full-time, while he worked, he commuted 3 hours a day back and forth to school because he lived in a suburban community, had a part-time job, did my program and went to school and did great. And he did it. That's what I did when I was younger. And he's amazing. And he's going to share his story with you. Every one of you can be the world's best cloud architect if you desire. Why am I there showing you architect things? Because I want you to be actual architects. So what time are we doing this on Saturday? We are doing this, Chris. What time are we doing this on Saturday?
You picked 12 o'clock.
12 o'clock on Saturday. For some reason, I had a different time in my head, but I must have picked it. So Saturday at 12 p.m. Eastern, which is 5 p.m. UK time, 5 p.m. Nigeria time, 6 p.m. Central European time for places like Cameroon as well as Central Europe. And so hopefully we see lots of you all there and it becomes a wonderful, wonderful, wonderful experience. So all of you have a super wonderful day. I really enjoyed spending some time with you guys today. It's been really, really amazing. Let me know I had a great time and type multi-cloud architecture design in the chat box, and then we'll finish the day. Pompano Beach, I'm not too far away from you there, Dana Wilson. I'm over in Port St. Lucie right now, but I was in Broward County just the other day. Thank you so much, Noel. Marjan, thanks so much. I know it's pretty late over there in Amsterdam. Saroon, excellent multi-cloud architecture. Alonzo, multi-cloud architecture. Robert, excellent. Noel, this way I know who's here, by the way, too. Fantastic. Amaranth, excellent job. Excellent, Amaranth. I'm so happy we're here for the multi-cloud architecture. Alonzo, cloud hard. Gotta love that, Alonzo. Marjan, all the time. Thank you so much. I'm so grateful you were here, Marjan. Ahmad, so happy to see you. Alonzo, really enjoyed seeing everyone here too. Alonzo's working with me on some very special projects, and I think you're going to see a lot more of Alonzo moving forward. Alonzo's a very close friend and a really special architect. Derek, I'm so happy to see you, multi-cloud architect. Kenya Carl, cloud hard remote. I love that. John Danjuma, a multi-cloud architecture. So nice to see you here. Theo Q, multi-cloud architecture. Thank you all for being here. It's an honor and a privilege to be with all of you. My students and I have created a family and I absolutely love it. But this whole YouTube extended community is also really fun too. So look forward to seeing you all on Saturday. Make sure you sign up for that free book because our AWS Certified Solution Architect Professional we're coming out is truly amazing. I would like to thank Chris Johnson. Alonzo, good point. Chris Johnson is my Chief Operating Officer, and he is amazing. Chris deals with me, which is a moving target, a hyperactive person that comes up with ideas 24 hours a day, and asking him, Chris, can we do this? And he's the one that either determines if it can be done or is the sanity check that says, no, Mike, seems like a great idea, but no, we can't build 16 cloud computing environments in 3 hours just because you have some students and you thought it would be fun. No, we can't replace all the cloud providers overnight. But these will be the kind of things that I like to do because I've got big dreams and I want to get all you guys cloud hired and build you all the best career. So when you guys are all hired and you guys are all expert architects and you guys all have networks of thousands and thousands of people, and you're out there, I'm going to go to Jamaica and I'm going to go practice Ashtanga yoga on the beach all day. I'm going to alternate between maybe Jamaica and Trinidad, or Tobago, two places that I really love, and just do yoga all day long. But I came out of retirement to get you guys all cloud hired. I'm having a ball. I'm super happy to be with you all. So thank you so much. Thank you so much, Mel. I so appreciate that. Thank you so much, Evo and Marla. Yeah, so let's give a hand of applause to Chris. Chris really tolerates a lot, so let's really appreciate Chris. Okay, everyone, take care. It was such an honor and privilege to see you. My students, tomorrow, we're going to have some fun. We're going to do some more leadership stuff tomorrow because we did some extra architecture today. I got some exciting stuff for all you guys. We're going to have fun tomorrow. So super nice to see you. Take care, everyone. Chris, while we're at it, in case anybody's not our student and they're interested, why don't we do this? Let's give a list to our link to our course, and let's give everybody a nice 20% coupon as well.
Sure thing.
Thank you so much. For anybody that stayed and paid attention to this much, we want to give people the opportunity to help them in every way they want. And there's no obligation. We're happy to work with you no matter what. But if you'd like to work with us, I just want you to have a nice coupon to make it affordable for you. So Chris will pop that in the chat real quick. After we do that, we'll sign off for the day. If anybody has any questions about our training, you can actually give us a call. I will actually put our phone number in the chat box below, which I know is one of those crazy things to do on YouTube, but I do it all the time anyway. Okay, everyone, multi-cloud architecture. This is Michael Gibbs signing off. I will see you all very soon.